Hi students, so welcome to Vedantu NEET English. I am Diksha Kaushal, your chemistry master teacher. And students, today we are going to do electrochemistry, a very important chapter of physical chemistry, right? And we have completed everything in physical chemistry. This is going to be the last chapter of physical chemistry. And from here, you can easily expect around 3 to 4 questions directly you can expect. And the questions are very predictable. Yes, everyone. Hello, Sneha, Trisha, Philo, Sukanya, Madhumati, Vikyats, Pratik, Maya. So, guys, are you all ready for today's session? If yes, then green hearts in the chat box and tell me if I am clearly audible and visible to you. Is there any blur on the screen? Is there any blurry text that you can see on the screen? If so, then let me know in the chat box. Yes. Okay, so let us start the session and also share this session with your friends, right? On your WhatsApp, on your Instagram, everywhere, on your WhatsApp groups, right? Where you share about everything, you can share about the knowledge also, right? Okay. Yes, everyone, with a very beautiful smile on your face and with a positivity, let us start the session. Firstly, tell me, how many of you are scared of this chapter? How many of you are actually, ma'am, I am not able to understand this chapter because this is one of my favorite chapters. It's a very interesting chapter. Unlike mole concept or, maybe ionic equilibrium, it's not something that you will not be able to understand only which formula to apply. Here you can easily understand that it is a direct thing that, okay, ma'am, this formula will be applied. Right? Why? Because it's not complicated because of the formulas that, ma'am, which formula to apply, that is not the deciding factor here. Here the important part is the application of formula. When you fill the values of what is 𝐂𝐸 cathode, what is 𝐂𝐸 anode, that is the important point, right? For that, you need to have a very good conceptual knowledge of this chapter. Also, theory is important. You just cram this is Nernst equation, ma'am, this is E is equals to E0. No. You should also know how to calculate E0 if nothing is given to you. You should also know how to calculate what is R, what is T, how to put oxidation and reduction concentration in which format, and how to fill the formula. That is the important part. Also, the units are very important here. Okay, have a session in, okay, Harish. So now let us start the session. Starting with the first thing, that is, firstly, so let us talk about two types of, here I will not say two types of electrochemical cells, rather say there are basically two types of cells that we are going to talk about, right? Two types of cells that we are going to talk about, right? What are these two types of cells? Two types of cells that we are going to talk about. Two types of cells. One is electrolytic cell, other is electrochemical cell. Ma'am, what was that galvanic and voltaic written there? That is a sub part of electrochemical cell, right? That we will study in electrochemical cell itself. So basically, the cells that you are going to study in this chapter, two cells basically. One is electrochemical cell, other is electrolytic cell. First part we are going to cover electrochemical cell, then we will cover electrolytic cell, both we will cover, right? And what kind of question we will discuss, at what kind of question they ask, and we will also discuss the previous year questions, right? So now, electrochemical cell, now you can just erase this thing here, right? You can just erase this thing here. You can just write electrochemical cell. You don't need to write galvanic cell here, right? It's not like galvanic cell is a wrong thing to write here, because galvanic cell is a subpart of electrochemical cell. That is why I have written, that is why I am writing electrochemical cell. Electrochemical cell uses chemical reaction to produce electrical energy, right? That means the difference between these two things is, here chemical energy is converted to electrical energy, but in this case electrical energy is converted to chemical energy, right? Here we will study apparatus where you have a chemical reaction going on, and after the chemical reaction, there will be flow of electrons which will produce the electricity. What is electricity? What is electrical energy? That is the flow of electrons only. So here, because of the chemical reactions, you will have the flow of energy, flow of electrons, that is your electrical energy. That is why chemical energy is converted to electrical. But in this case, you will already have electricity, you will pass you have discussed about electrolytic decomposition. That is a case of electrolytic cell only, where you pass the electricity, and after that your compound is giving you some chemical reaction. That is called your electrolytic cell. So firstly, let us talk about these two cells only. Then what about these two cells? What is the differentiation? What are the different points of these two cells? So I am writing it here, right? Electrochemical, and here it is electrolytic. Now, if you talk about electrochemical cell, we can say that in electrochemical cell, chemical energy is converted to electrical energy. Is that the right point? Chemical to Ce. You can just listen, where you have E and C both, then C will be converted to E. When you have only electrolytic, here definitely electrical energy will be converted to chemical energy. Electrical energy will be converted to chemical energy, right? Now next thing is, just wait a minute. Don't spam here, okay? Don't spam here in the chat box. Otherwise, so I'll have to just block you. Okay. Okay, wait a minute. I can't see your chats, guys. Write something in the chat box. Yes. Now, chemical is converted to electrical. Another differentiating point here is loan. What is the differentiating point? Loan. What is, ma'am, loan? What is, ma'am, loan? It is not your bank loan, right? It is not your bank loan. It is a loan of chemistry. What is this loan? Loan is applicable for electrochemical cell. That means loss of electron, yes. O means oxidation. A means anode. But in case of electrochemical cell, anode is negative in nature. Anode is negative in nature. But when you talk about electrolytic cell, it's not loan. Rather, it's L-O-A-P. LOAP. So you can just remember loan for electrochemical cell, right? Because here we have, yes, loss of electron, definitely. Yes, loss of electron means oxidation. Yes, oxidation means we are talking about anode side. At anode side, oxidation will happen, right? And oxidation means loss of electron. And what is this P? P means your anode is going to be a positive electrode, right? What is this cathode and anode? These are electrodes, right, with a proper charge, right? When you talk about cathode and anode, according to the cell, the charge will vary. For example, you can write it here in a box, or you can just simply write it. In electrochemical cell, anode is, in electrochemical cell, anode is negative. Anode is negative. Cathode is positive. Cathode is positive. But when we talk about electrolytic cell, the case is completely opposite here. Here anode is positive, but cathode is a negative. But cathode is negative, right? So this you need to understand, because most of the students, they get confused in this. Ma'am, should we take a node as negative or positive? So it depends on which cell we are talking about. So in the start, I am going to talk about, we are going to focus on electrochemical cell. So wherever I am talking about anode, we are thinking that this is a negative electrode, right? That is a negative electrode in case of electrochemical cell. Now let us see how the electrochemical cell works, right? This is not important, Abhi, Right now, so this is not important. Now let us just see how electrochemical cell works. Now basically in an electrochemical cell, ma'am, what is this Daniell cell? Daniell cell is a type of electrochemical cell only which is majorly studied in chemistry, right? So what is Daniell cell? It is according to the scientist name it is given, right? So in this he specified the cathode and anode. What he specified, the Daniell cell is type of electrochemical cell invented by John Frederick Daniell. By the scientist name you have this the name of this cell. Now it is galvanic or voltaic cell with copper and zinc. Now what we are saying here, wait a minute. Firstly, three things we have. One is Daniell cell, other is galvanic and voltaic cell. Ma'am, what is the difference between all of these things, right? So first question will be, what is the difference between all of these things? So I'm going to write it here only, right? Okay, wait a minute. Three things we have. If you talk about electrochemical cell, this I told you. So we study one thing, that is Daniell cell in electrochemical cell. And what is Daniell cell? Daniell cell has zinc and copper as the electrodes, right? It has zinc and copper as the electrodes. And it has zinc sulfate solution, copper sulfate solution, that I will show you what is exactly Daniell cell. Now, here the concentration is not specified. But if you specify the concentration, if concentration is 1 molar, then this Daniell cell is called galvanic cell or voltaic cell, or voltaic cell, or voltaic cell. So basically, right, that's why in replacement of electrochemical cell, they have written galvanic sometimes, they have written voltaic sometimes they are writing Daniell cell, right? These all are the same things only, right? So electrochemical cell is a general term. Daniell cell is when you specify the electrodes and when you specify the solution. That, for example, ma'am, we have these two things, right? Here, ma'am, I have ZnSO4 solution. Here I have CuSO4 solution. Here the rod is zinc. Here the rod is copper. This is the Daniell cell, right? If I am specifying that my concentration of solution is 1 molar, then I am saying that this Daniell cell will become galvanic or voltaic cell, right? Okay. Right, students? Okay. Yes. Next is, let us talk about what is exactly this Daniell cell and how we can study this Daniell cell. So basically, this is the Daniell cell. Are you able to see this? Are you able to see this, or should I draw the diagram myself? Now, this is basically a Daniell cell. In Daniell cell, you have two things, okay? If you want me to draw it myself, I can even draw it myself. If you are able to see this, I'll just explain you here, right? So now, this is basically your Daniell cell. Now here, what we are doing, right? Let us see what exactly we are. I think you are not able to see this, right? So I'll draw it myself only, right? So basically, what we are doing here, yeah, I'll have two beakers here. Okay. Now I'll draw two beakers, right? Two beakers you will have, right? In one side, what you will have? One side you will have a solution of ZnSO4. This is a solution of ZnSO4, right? This is a solution of ZnSO4. And here you have an electrode. Here you have an electrode, that is an electrode of zinc only. Right, and here you are having a solution of CuSO4, right? You are having a solution of CuSO4 copper sulfate, and the rod is of the same thing. Here you have a rod, that is your copper rod, right? This is your copper rod. So now I am going to fill this solution above here, right, and here. Now let us see what are the different things that can happen, right? Okay, what are the different things that can happen here? Right, so I'm drawing it here. What are the different things that can happen? So first is, what is my cathode and what is my anode? So always remember, anode and cathode. Cathode is your right side and anode is your left side, right? Anode is left side, cathode is your right side, right? So, and at anode oxidation will occur. At cathode reduction will occur. Right? So, now I am going to write it here. At anode, what will happen? At anode, I'll talk about salt bridge and everything in the end. Right? Firstly, I'm just giving you just an overview of this thing. Right? So, now, firstly, what will happen? At anode, we know that oxidation, this is basically my anode part. Right? This I am saying is my anode part, and this is my cathode part. This is my cathode part. So, at anode, I am saying oxidation is going to happen. That is, loss of electrons is going to happen. Loss of electrons can happen by an atom, right? So, for example, you are talking about an atom, that is your zinc, right? Zinc, from the electrode, it is going to lose the electrons and it is going to give off 2 electrons, is it? Is it? Zinc is going to lose 2 electrons. This is, I am drawing Daniell cell, right? So, here it is going to lose 2 electrons, right? This Zn SO4 is existing as Zn2 positive and SO4 2 negative, right? So, this cannot lose further electron. Zinc is stable in Zn2 positive. So, it will lose 2 electrons here, right? If you talk about, ma'am, what will happen at anode? Ma'am, what will happen at cathode? Ma'am, what will happen at cathode? So, let us see what will happen at cathode. Now, let us see what will happen at cathode. At cathode, there is a reduction. I told you, just remember one thing, LOAN. L means left side, L means loss of electrons, O means oxidation, A means at anode, and N means it is a negative electrode, right? All these things, just remember LOAN for your electrochemical cell, right? So, this is left side is anode, and at anode you have loss of electron, which is called oxidation, and this thing is called as anode, and that is a negative electrode. That means, can I say that the zinc is going to be a negative electrode, right? Why it is going to be a negative electron? Can you tell me why I am saying anode is a negative electrode? Because at anode, it is going to lose 2 electrons, right? At this point, it is going to lose 2 electrons, and the thing in which you have connected these two things, right, which is a conductor only. This should be a conductor. Why this should be a conductor? So, the electrons that are getting out of this oxidation part, they can flow to this side, right? They can flow to this side. That is why this thing should be a conductor only, right? A conductor, right? Not an insulator. Insulator like rubber, plastic, these are insulators, right? Okay, any metal, that is a good conductor, right? So, here you have connected this, and here what will happen? Electrons will be generated here, and these electrons will try to flow to this side. Because right now, this anode is a negative electron, that means it is a anode. Right now, you understood why this anode is negative. Why this anode is negative? Because it is giving out electron, right? It is giving out electrons here, right? Now, let us understand what will happen at cathode side. Now, cathode means gain of electron. Who can gain the electron? You have copper atom, you have Cu2 positive ions. So, definitely ion will gain the electron. So, here what will happen? Cu2 positive ions will gain the electrons only that have flowed, same amount of electron will be gained, right? And this will give rise to copper, right? This will give rise to copper. Now, very important point to understand here. This Zn, this zinc atom that are losing the electrons is from anode, right? So, can I write here that this basically, this thing is from anode, right? And what about this Cu2 positive? And what about this Zn2 positive? It is giving more ions to the solutions. It's like when you are dusting off your, maybe some dust on your shirt, when you are dusting it off. The same way, this electrode, this anode electrode is giving out electrons. The electrons are going to this side, and the ions, that is Zn2 positive, that are coming in the solution, right? They are going in solution. Right? If you talk about this Cu2 positive, that is already in the solution. That is already in the solution. Already in solution. Now, you are making it gain 2 electrons that you have given here, right? It has taken out electrons from the anode. Electrons are flowing, electrons are flowing. Now, this copper 2 positive ion will catch these electrons and they will become copper. And now this copper will be distributed on this electrode, right? This copper will be distributed on the electrode. Distributed on electrode. That means, can we see two very, very important things here? Two very important things here. What are these two important things? That, ma'am, exactly what is happening here? Exactly what is happening here? That, wait a minute, let me make some space here, right? Okay. Now, can you see one thing? The thickness of electrodes. Ma'am, what is the thickness of electrons? Now, let us see the thickness of anode. And let us see the thickness of cathode. Thickness of cathode. Any idea about what will happen here? Now, here rod is doing which thing? Rod is like, I am losing my atoms. I was firstly 100 atoms. Now my maybe 30 atoms, they have become Zn2 positive and they are in the solution. So I only have 70 atoms now. So you have taken up atoms from me, right? I had 100 atoms and now I have, for example, you have 100 rupees earlier, right? You buy something and now you have only 70 rupees. So number of rupees, right? The number of money has decreased in your account, right? So in the same way, the electrode, right? The thickness of the electrode has decreased because some of the atoms, they have converted into Zn2 positive, right? So can we say that thickness of the anode will decrease? Thickness, again, this question is directly asked, right? These kind of questions can be directly asked to you. That in a Daniell cell, what will happen? Thickness of the anode will decrease here, right? And ma'am, what about the thickness of the cathode? Ma'am, what about thickness of cathode? Will it decrease or increase? What about thickness of cathode? Will it decrease or will it increase? If you talk about the cathode side, this side, on cathode, the ions in the solution, right? Chidam, don't worry about that. I will also start that, right? Right now, just focus on electrochemistry. We are just left with electrochemistry, amines and bimolecules, right? Then we are left with P block also, right? So 3-4 chapters we are left with. We will complete this, I think, before the end of this month only, right? So next month we are going to start that, okay? Now focus here. Now it is going to increase. Why? Because the ions in the solution, they are going to catch the electrons and they are going to deposit on this electrode, right? So that means the thickness of the cathode will increase. Thickness of the cathode will increase. That is a very, very important point here. Very, very important point here. So what will happen here? This will decrease if I have to draw this. If I have to draw the new thing, so what will happen? This is going to decrease. Or if I want to use a highlighter to draw this thing, what I can do, this is going to decrease like this, okay? This is going to decrease like this, right? Some of the part will be decreased, right? And what about this? It is definitely going to increase. It is definitely going to increase, right? Not in a symmetrical manner, but it will definitely increase, right? The thickness is going to increase, right? So that was about cathode and anode. What is the thickness? Now, can you see one more difficult part, one more tricky part here? That, ma'am, what is happening here? In the anode side, what is happening? The concentration of Zn2 positive ion is increasing. That means in anode side, if you talk about anode side, positive ion is increasing, right? And if you talk about at cathode side, what is happening? Your positive side is decreasing, your positive ions are decreasing, that means negative ions are increasing, right? That means negative ions are increasing. So can we say that this is now it has developed a you can say it has developed a potential, right? Why? Because it is now positive, it is now negative. So now this cell is not electrically neutral. So now this cell will stop working, right? That is why what we have to do, we have to add a thing that is called salt bridge. What is that called? That is called a salt bridge. Okay, the name is salt bridge. And what is the work of salt bridge? What is the work of salt bridge? Everybody, what is the work of salt bridge? Salt bridge. Salt bridge will basically, what it will do, it will create a electrical neutrality. Electrical neutral, salt bridge I will write there only, right? Here I will write salt bridge, right? So what a salt bridge will do? A salt bridge is basically a U-shaped tube, right? If I have to draw a salt bridge here, okay, what I should use, I am using this red pen, right? If I want to draw a salt bridge here, so what I will do, that is a U-shaped tube, right? In which you have a electrolyte filled, right? It is a U-shaped tube, right? First thing. Second thing is, you will fill a electrolyte, and the condition of that electrolyte is that, mobility of cations and anions. Everything that I am writing on this page is very important. Mobility of cation is equal to mobility of anion. Right? So what we have discussed here, that there is a salt bridge. It will create electrical neutrality. It will try to balance out the positive charge that has increased here, the negative charge that has increased here, right? Because the ions has converted into the atom, that is why negative charge, that means SO4 2 negative has increased here, Zn2 positive has increased here. So we need to add a electrolyte. So that is why they are saying mobility of cations and anions should be same, so that with the same speed, one cation is jumping into this solution, and with the same speed, an anion should also jump into this solution, right? Okay. Now, the same thing that I talked about here, that what should happen? If you have any electrolyte, let us talk about electrolyte, for example, KCl, KNO3, all these are very good electrolytes, right? So, in these things, in these electrolytes, which should, if you talk about, it has two parts, K positive and Cl negative. So now if you want to talk about K positive should jump on this side or K positive should jump on this side. I know that on the anode side you have positive, on the cathode side you have negative. So to neutralize this positive, I need a negative. That means the anionic part, that means can I say that the anionic part will go to anode, and the cationic part of electrolyte, it will go to cathode. The cationic part, that means the positive part, will go to this side, that means K positive to neutralize the SO4 2 negative, right? And the anionic part will go to this side to neutralize the positive charge here, right? Okay, students? Yes. Yes, students. Okay. Now, thank you, beta, thank you. Now, next thing is, this is important. Now, next thing is very, very important, that if they ask you, what is the flow of electrons? Before the flow of electrons, one more important thing about salt bridge, that we use agar-agar solution. Now, what is agar-agar solution? That is a thick gel paste, right? So that we don't want the electrolyte to jump like 1 ion, 2 ion, 3 ion, 4 ion. We want it to have viscosity. We want it to be viscous, so that one by one it can jump, so that we can balance the electrical neutrality here, right? Okay. Now, second thing is, what is the flow of electrons? If you talk about flow of electrons here. If you talk about flow of electrons, what we can do? If you talk about flow of electrons, what we should do? If you talk about flow of electrons, what we should do? With flow of electrons, we can see that the electrons is going from zinc to copper side. So can I say electron is going from zinc to copper side? Right? If you talk about current, what is the flow of current? So this you have studied in physics, that current is opposite to the flow of electrons. So if electrons is going from zinc to copper, so the current will flow from copper to zinc. So we can write here, it will flow from copper to zinc, right? Flow of electron is from this side and the current will flow in the opposite direction, right? And the current will flow in the opposite direction, right? Okay, students, everybody in the chat box, is that clear? Yes. Let me see if there is any important point. Yes. Take a screenshot of this. This page is very, very important for all of you, because why I am writing it like this? Because I want you to make your own short notes also. If you don't want to make your own short notes, then you can do one thing here, that if you are like, ma'am, I don't want to make my own short notes, right? So what you can do here, you can just take a screenshot of this particular thing, right? Okay? Yes? Very good. Now, or you can also go through the flashcards that we have for you, right? So flashcards are even more interesting, right? Even more valuable to you, right? So now, let us talk about, this is the same thing, I'll just repeating this thing again, right? So, in a very fast forward manner, we will see this. Due to oxidation occurring at zinc strip, it becomes source of electrons, right? We will have electrons there and acquires a negative charge, right? It will acquire negative charge. That is why we are saying that anode is negative. Due to reduction, the copper strip, this copper strip they are saying, it will receive the electrons and acquires a positive charge. That is why this cathode is positive here, right? Then we have, now next thing is, now they are not talking about, they have talked everything about what is Daniell cell, everything, right? Now they are saying that, for example, you are applying some external potential, right? You're giving it some external potential. For example, this is your cell, and to this cell, I am giving it some external potential. This is my external potential. So there are three cases, right? Here we are talking about only Daniell cell, that if your external potential is less than 1.1, for example, the Daniell cell has a potential of 1.1 volt, right? Okay. So for example, you just think about that, if you are, you have taken up, you have planned to do something, right? For example, you have planned for a trip, right? You have planned for a trip to Manali, right? To Ooty, right? You have planned a trip for Goa, right? So now, what is going to happen? This external potential is your parents, right? If the potential of parents is less, it means if the force by the parents is less, then your plan will go as it is, right? So that means here also the external potential is less than 1.1. That means there is no change in the Daniell cell. So it will stay as it is. That means electrons will flow from zinc to copper only, the same way it was doing before, right? The current will flow from copper to zinc, that the same way it was doing before, right? And zinc dissolves at anode. Zinc will, the thickness of zinc will decrease, anode will dissolve, right? And copper deposited at anode, right? Copper will start depositing on the cathode. That is the same thing that has happened in Daniell cell. Nothing will change. But now, for example, you are also fighting, your parents are also fighting, the force is equal, right? So the current will stop only, right? The current will stop. How the current will stop? The flow of electrons will stop, right? Because equal force. For example, you are in a tug of war, right? So when you are pulling something, right? If you don't have that much force, right? So the other person will do the same thing that they were doing before, right? If you have equal force, so there will be balance, right? Because of this balance, the no flow of current will be there, right? No flow of electrons, no flow of current, and there is no chemical reaction that will occur in this case. You will stay as it is. But if your parents' force is very high as compared to you, then what will happen? Instead of Ooty, you will go to Vrindavan, right? So instead of Ooty, you will go to Vrindavan, right? So what will happen here? Applying an external potential. When your external force is very, very high as compared to the Daniell cell, what will happen? Current will flow in the opposite direction. That means electrons will flow from copper to zinc now, not from zinc to copper. And the current will flow from zinc to copper, right? So the zinc deposited, that means everything is opposite. So in this case, the thickness of the zinc will increase. The thickness of zinc will increase and the thickness of copper will decrease, right? So zinc is deposited, but copper is dissolved. That means the thickness of copper is dissolved. So everything is opposite, right? Things will be opposite. Things will be opposite. Okay? Understood? It's a very, very important question, right? Next is, here though they are telling about Daniell cell only, right? That we have already talked about, right? This also we have already talked about. Let us study some theory points of salt bridge, right? So basically, what is a salt bridge? A salt bridge is U-shaped tube complete circuit by facilitating flow of ions. It contains semi-solid paste of some inert electrolyte like KCl, KNO3, NH4Cl in agar-agar and gelatin to have that thickness of the solution, right? End of the salt bridge are plunged with glass wool. Now, why there is a glass wool over here? For example, this is your salt bridge. You will see a glass wool over here, so that the electrolyte, the ions can flow one by one to decrease the speed of the electrolytes, right? Basically for that, right? Okay, yes. Saundarya, we are giving you NYTS, right? That is your NCERT based test series. You can go through that. 25 tests will be available to you and the link is in the description, right? So if you're looking for a good practice mock test and test series, so you can go through that. It's a very, very 25 questions. Video solutions are available to you. Moreover, you have not only video solutions, you will have your report analysis also. You will have, it's not like it's full syllabus mock test. It's also sometimes full subject mock test. For example, one is chemistry, one is bio, one is physics, right? Then there is full syllabus mock test also, right? Then there is half syllabus mock test also, right? So you can go through those 25 tests and I think you will be sorted, right? Now, next is salt bridge. Now, ions of the electrolytes do not react with ions of the electrode solution, right? Neither oxidized nor reduced at the electrodes. Salt bridge maintains electrical neutrality. K positive ions move to cathode. That means cations move to cathode. Anion moves to anode. That I have already told you, right? Okay. Now, next important thing. First was your Daniell cell, understanding the Daniell cell, right? Second important thing is electrode potential. Understanding what is this electrode potential, right? So electrode potential is because of the difference. Whenever you will see electrode potential, that simply means if you have positive somewhere, right? And then you have a negative here. So now there will be development of some potential because of the difference in the charge, positive and negative charge. That is called potential, right? When there is potential in this electrochemical cell, that is called electrode potential, right? So now let us see this, the potential difference which facilitates the flow of electrons between two phases is called electrode potential. We are saying that one is anode, other is cathode. If one is anode, that is why from one point to other point the electrons are flowing. It's like when we are saying that you have, this is a mountain, right? From this mountain, the water is flowing. The water is flowing. Why the water is flowing from that mountain? Because one thing is at height, other thing is at the ground. That is why the water is naturally flowing from that side to ground, right? So that is the difference, right? So same way, if you have a positive on one side and if you have a negative on one side, because of this difference, they will develop a potential which will facilitate the flow of electrons here, right? Okay, so now what is the type of potential? So basically we have two types of potential. One is reduction potential, other is oxidation potential, right? And our whole electrochemistry is based on the study of, like, most of the electrochemistry questions you will see, right, directly based on electrode potential, or somewhere in your numericals also you will see electrode potential, right? So now you need to understand one thing, that when you talk about the reduction, in this case you will gain the electron, the ion will gain the electron and then become an atom. When there is gain of electron, then we are talking about the electrode potential, that is called reduction electrode potential. But when we are talking about oxidation electrode potential, that means we are talking about loss of electrons. In loss of electron, the electrode potential is called E oxidation, right? Okay, now let us talk about this thing over here. What is standard electrode potential, right? Now let us talk about what is standard electrode potential. Standard electrode potential means the conditions are standard here. We are talking about 1 molar, we are talking about, for gases we are talking about 1 atmospheric, and the temperature is fixed to 298 Kelvin. If all these conditions are fixed, then we say this is standard electrode potential. It is denoted by this naught, this 0 over there. In the power you will write that 0, that means we are talking about standard conditions, right? So if nothing is mentioned about the type of electrode potential, it is assumed to be reduction electrode potential. Now what we are talking about this thing here. So for that we need to know two things. First thing is, what is the relation between E naught, not E naught, E reduction and E oxidation. If you talk about E reduction and E oxidation, if they have given you E of reduction, for example, they have given you A plus, or you can say A2 positive plus 2 electrons give rise to A. And they are saying the electrode potential here is X, right? So here they have given the electrode potential as X. That means the oxidation potential will be minus of X, right? Similarly, for example, they have given you B give rise to B2 positive plus 2 electrons. That means here the electrode potential will be oxidation potential. So here if they have given you oxidation potential as X, then your reduction, or I'll say Y, then your reduction potential will be minus Y. That means you multiply this by minus and you will have the reduction potential, or you multiply this by plus minus, you will have the oxidation potential, right? Okay, this is a very important thing. Right now you must be feeling that, ma'am, this is so simple, but when you will solve the numericals of Nernst equation, these things will be very useful to you, right? Now next thing is, ma'am, what you are talking about a standard condition. For standard condition, I talk about E naught reduction and E naught oxidation, right? So how they will mention this thing, right? So for example, they will not write that this is reduction, they will mention it like this: E naught of A2 positive 2A, E naught of B2 positive, or you can say B2 positive. Now you have to understand by this thing only that whether they are talking about reduction potential or they are talking about oxidation potential, right? So now as I can see here, it is A2 positive is converted to A by gaining of 2 electron. That means here they are talking about E naught of reduction potential. Then the second thing is, here they are talking about that this is converted to B2 positive, right? So that means it must have lost some electrons, right? So loss of electron means they are talking about oxidation potential, right? If they have not mentioned anything, if nothing mentioned, this will not happen basically, but yes, if nothing mentioned, then what you will say? Then you will say that they are talking about E0 of reduction, right? Because standard electrochemical series also, your reactivity series also, we talk about reduction potential. That is why if nothing is mentioned, you will say that, ma'am, yes, they are talking about maybe reduction potential only, right? Okay, if nothing is given to you. Now, next thing is, ma'am, what is the relation? Why you are focusing on reduction potential so much? So, our main task is to understand what is E0 of cell, right? What is E0 of cell? The electrode potential at standard condition of this full cell. That is going to be, what it is going to be, there are two things what you have, right? You have one anode and you have cathode. So, at cathode, you will have reduction potential, and at anode, you will have oxidation potential, isn't it? At anode, you will have oxidation potential, at cathode, you will have reduction potential. Now, we know that the reduction potential, as I told you, that while calculating E0 cell, you can calculate, you can directly put the value of E0 anode and oxidation potential of E0 anode, put the reduction potential of E0 cathode. But by convention, scientists agreed that we will only talk about reduction potentials. Whenever we are solving something, we will talk about reduction potentials, right? So here they said that keep it as it is, right, reduction potential. But we know that if we want to take out the reduction potential of this E0 anode, that will be minus of this. So it will be minus of E0 anode reduction potential. And this is the formula that you see everywhere that says E0 of cell equals to E0 cathode minus E0 anode. But here important thing to note down is that they are not talking about oxidation potential, they are talking about reduction potential, right? So in the question, if they have given you oxidation potential, right, you will firstly convert it into reduction potential, right? Then you will put the values, right? Firstly convert it. You should have a standard thing in your head. So I will say calculate everything on the basis of reduction potential only. So firstly calculate reduction potential even if oxidation potential is given to you. Only after that calculate the value of E0 cell, right? Only after that calculate the value of E0 cell. Tell me if that is clear to you or not. Yes, students? Yes, students, if that is clear to you or not? Yes. Okay, now this is the same thing, right? Then let's talk about a reaction, right? So this is a reaction that is mentioned to you here, right? This is a reaction, they have given you one reaction here, right? Now, in this reaction, as you can see, there are two parts. Firstly, you need to divide any reaction in redox reactions. We have studied about this, that if something is given to you, you convert it into cathode and anode side, right? So we know that here copper is getting converted to Cu2 positive. That is definitely there is loss of electron. That means copper to copper positive is anode and this is oxidation, right? From Ag positive to Ag, that means there is gain of electron. How you are saying loss and gain of electron? How you are saying oxidation and reduction? So just simply remember, in oxidation number increases. In reduction, you can just simply write it somewhere also, right? In oxidation number increases, right? If you're not able to understand, ma'am, where is reduction, where is oxidation, then this is a simpler way. Then you can say oxidation number decreases. Here it is going from 0 to plus 2. That means oxidation 0 to plus 2. That means number is increasing, right? So it is oxidation. Oxidation is at anode. Here it is going from plus 1, or I would say after balancing it, it will be, after balancing the equation, it will be plus 2 to 0, right? This we have studied in redox reactions, right? So here we can see that it is going from plus 2 to 0, right? That means here oxidation number is decreasing, right? It means it is reduction, and that will happen at cathode site, right? So now we know that here this is cathode, this is reduction, this is oxidation. Now how to represent this cell? Now how to represent this cell, right? And how to write the value of E0, right? So firstly E0 will be written as, E0 cell will be written as, firstly so I will say okay, I'll just delete it, I'll write it myself only, right? So now if you firstly want to write the E0 cell, that is going to be E0 of cathode. What is cathode? Cathode means Ag. Ag means you want to write the gain of electron, that means Ag positive to Ag, right? Minus of anode. Anode means this thing. Here also you need to write the reduction potential. That is from reduction will be from copper 2 positive to Cu. So it will be Cu2 positive to Cu, right? How many of you are able to understand this thing? That here what we are doing, this is anode, this is cathode side, this is anode side. We have to write the reduction potential of both of them. And here students usually get confused, they write the oxidation potential here. But you have to write the reduction potential. Reduction potential is opposite of this thing. So it is Cu2 positive to Cu, right? Okay, understood? Now, if you want to do the representation of this, right? Representation, always remember, it is, you have a salt bridge in the center. The two straight lines are representing the salt bridge. Then if you are changing the phase, right? For example, here it is in aqueous solution. It is going from aqueous to solid. That means you are changing the phase. Then you will mark one line here, and it is going from Ag. That means firstly you will write, no, firstly you will write anode, right? Firstly you will write anode. Basically you just remember this by AC. 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 That means anode first, then cathode. Anode, then cathode. Firstly we will write anode, then we will write cathode, right? So how you will write anode? Anode is what? Your oxidation, right? So here oxidation is this thing. So it is going from copper to positive. Here you should write what is happening in the reaction, not the oxidation reduction. This is your anode part. In the anode part, it is going from Cu to Cu2 positive. But in the cathode part, it is going from, Ag positive. It is changing to Ag. Now here, as your phase is changing, this is solid, this is aqueous. That is why one line, right? This is aqueous, this is solid. If your phase is same, for example, in some question, you will rarely see these kind of questions. But for example, in some question, you have even iron in aqueous, even the solid part is in aqueous. Then you will put a comma over there, right? There will be a comma over there, not a straight line, right? So straight line is representing the phase change. This double line is representing the salt bridge, right? So this is basically the representation. Just remember this, right? It is AC. Always it is anode, and then you will write cathode, right? When you talk about E0 cell, E0 cell is what? E0 cell is cathode minus anode, right? This is the value of E0 cell. But when you represent something, it will be, firstly you will have a salt bridge, then there will be a one line, and here you will represent anode, here you will represent cathode. For example, it is going A to A positive, this is B positive to B, right? Okay? Any problem here? Any problem in this calculating A0, what is E0, how to represent this, right? Okay, now let us see what is SHE, right? She is coming here also, right? She is coming here also, guys. She is coming here also. Now she is not your ghost. She is standard hydrogen electrode, right? Standard hydrogen electrode. Like when we understood about atomic masses, right? We took carbon 12 isotope as the standard, Right? In chemistry, we are always taking something as the standard. Even while studying inductive effect, even while studying different things, we mostly try to take hydrogen as the standard. Right? So, keeping in standard thing here, we are keeping hydrogen as the standard. Right? So, depending upon hydrogen is on the, why we need to take hydrogen as the standard, because it is the lightest metal. Right? That is why we are taking hydrogen as the standard. So, now with respect to hydrogen, scientists will perform experiments and they will give you reactivity series based on that. Right? Based on the experiments that they will perform. Right? So, now let us see what is happening in this SHE, standard hydrogen electron. So, in SHE, what happens here? You will have a beaker. In this beaker, we have specified that you will have 1 molar H positive ions, right? And then you will have hydrogen gas at 1 bar. The pressure is going to be 1 bar. So, you will put the pressure, right? And this is the solution. What will happen? Here finally divided platinum. Basically, this thing is your finally divided platinum here. Platinum is acting as an electrode here, right? Which is an inert electrode, which will not react here, right? So, inert electrode means this will just behave as electrode, it will not take part in this reaction. You cannot see any reaction with this platinum, right? It is just an inert electrode. Zinc and copper were not inert electrodes. They were taking part in the reaction. Here, this platinum is not going to take part in the reaction, right? So, now here what you will see, here H positive ions, 2 things can happen, right? 2 things can happen. If you have this hydrogen SHE on the cathode side, then what can happen? If it is on the cathode side, if I have put this thing on the cathode side, right? For example, on my anode side, I have something. For example, I have copper or anything, right? Zinc I have. And on the cathode side, I have SHE. Value, for example, at anode side, I have copper. Or you can say, yes, copper. Let us say we have copper, or let us say we have zinc, right? Or anode side, you will have different things, right? So, here SHE is acting as a cathode. So, what it will do, in this case, what SHE will do, it will gain the electrons, right? This H positive ion is going to gain the electron and convert into H2 gas, right? And then this is the full equation that you will have, right? Here I am just talking about when this is behaving as a cathode. Now this SHE can also behave as anode. This is a simple expression that they have given you. Here though they have not mentioned anything that your SHE is behaving as cathode and anode, but I am giving you a further aspect of this, that how you can make this, right? And here one important thing is the E0 of SHE is 0. That is why it is easy for us to predict the E0 of other things, other metals, right? Because E0 of SHE is going to be 0 volt. Now, this is important part, that here they are saying that how to measure with the help of SHE. Now, the first thing is the potential individual of half cannot be measured, hence it is calculated against SHE. Now, firstly, they are saying that in the first case, here they are saying that we have taken SHE as anode and we have taken any other thing as cathode, any other metal as cathode, right? That you have 2 things, you have full electrochemical cell, anode and cathode. Anode you have taken SHE and this is some other metal. You want to calculate the electrode potential of this metal, right? So, in this case, what will happen? In this case, what will happen? They have given you example of copper, that we have taken copper as the cathode compartment, right? So, now to calculate E0 of Cu2 positive, because we know that if you are taking this as cathode, if you are taking cathode as copper, we know that at cathode side there will be gain of electron. That means Cu2 positive will gain electrons to get converted into, I am just going to write it here, right? At cathode, what reaction will occur? At cathode, Cu2 positive ions will gain electron and convert into copper. At anode, what will happen? You will have, because SHE is behaving as anode here, so it will lose the electrons. So half of H2 is going to lose the electrons and convert into this thing, right? Half of electrons, or you can just directly write this thing. H2 is converted into 2H positive to give off 2 electrons. So these are the two reactions that will happen, right? So all over what you can say that in SHE you have platinum electrode, which is an inert electrode, but in the cathodic side you have copper electrode, which is not the inert electrode. In this, copper is going to take part in the reaction, right? That is the first thing. Second thing is, here we are saying here H2 is converted to H positive, right? Your H2 is getting converted to H positive. But in the cathodic compartment, your Cu positive is getting converted to the Cu, right? That is why it is mentioned here. In the reaction part, it is mentioned. But your platinum electrode is not taking part in the reaction. So this is basically the representation, because they have mentioned here this is 1 molar, 1 molar. So they have written that in the bracket the concentration is 1 molar, right? Okay. So if concentration of reduced from this is this, so you don't need to this. So basically they are saying if the concentration of reduced form is concentration of oxidized form of species in the right half cell, then E0. Basically what they are saying that we know that E0 cell is equals to E0 reduction, E0 cathode minus E0 anode, right? We know that this is E0 cell equals to E0 of cathode. What is cathode? Cathode is copper, right? Minus E0 anode, E0 of SHE. That is going to be 0. So your E0 of cell, experimentally you will see what is the electrode potential of this cell. That is equals to the electrode reduction potential of copper. Because here we have taken copper as the cathode side. So it is a reduction potential. So similarly you can do so many things, right? You can even take it as anode, as cathode. Here they have taken it as cathode. If you take it as cathode, then things will be different, right? Then things will be opposite, right? If you take it as anode, for example, at cathode you have taken SHE. So it will be H positive, it will gain electron and it will become H2. At anode, for example, you have taken zinc. So zinc will lose electrons and become this thing, right? So overall representation will be, here it will be Zn, anode side is Zn to Zn2 positive, right? Salt bridge. Then you will have the cathode side is from H positive to H2, right? And also there is platinum electrode, right, which is inert electrode, right? Then you can say that E0 of cell is equals to E0 of cathode. What is cathode? Cathode is your H positive to H2 minus E0 of anode, right? If you want to write the oxidation potential, reduction potential here, you will write it as Zn2 positive to Zn, right? That will become your reduction potential, right? This will become equals to 0, right? This is become equals to 0. So you will write it as E0 of cell, whatever you will get. Or you can say E0 of Zn2 positive to Zn, that is the reduction potential, is equals to minus of E0 cell. That whatever you will get in this experiment, negative of that is going to be your E0 reduction potential of zinc, right? Okay, this is how, what is the use of SHE, standard hydrogen electrode, right? Is that clear to everybody? Cathode reduction potential, how? Now are you able to understand and visualize how things are happening? Yes, everybody? Okay. Now let us see one question based on this. The question says that, this is 2011 question that says that standard electrode potential for SN4 positive. What is it? Standard electrode potential for SN4 positive to SN2 positive couple is 0.15 volt. and that of Cr3 positive. So this is this. These two couples in the standard state are connected to make a cell. The cell potential will be. Here what is happening? Plus 4 to plus 2, that means it is a reduction. Here it is plus 3 to plus 4, that means again here also it is decreasing. Standard electropotential of this couple is this, and that for this is this. These two couple in the standard state connected to make a cell. The cell potential will be. Okay. Okay. So in both the cases, they have given you the reduction potential only. Right? So they have given you the reduction potential of 0.15 volt, and they have given you the reduction potential of this thing. Here one more thing you need to understand, okay, before solving this question. One more thing you need to understand. To understand which will behave as a cathode and which will behave as an anode, you need to understand this simple thing here, that your standard reduction potential is directly proportional to the oxidizing power, right? Standard reduction potential is more. That means if you talk about in the form of, let us talk about in the form of, if it wants to get reduced or oxidized. More is the standard reduction potential, more it can get reduced. It can get reduced itself. It wants to get reduced itself, right? Then if it wants to get reduced, it would not want to oxidize someone else, right? So less is the wait a minute, yeah. If its reduction potential is more, then it would want to reduce itself and it would not want to get oxidized, right? Its oxidation potential is less. That means oxidation potential is less. If you talk about the oxidizing and reducing power, if itself is getting reduced, that means it would want other thing to get oxidized. What does that mean? What is oxidizing agent? What is oxidizing power, right? That means if that element wants to get reduced and it wants to get oxidized someone else, right? If it is getting reduced, if your A is gaining electrons, then it can only gain electron if it can make someone else to lose their electron. So that means if my reduction potential is high, I would want to get reduced, then I would want to oxidize someone else, right? Okay, so that means my oxidizing power is very high. Oxidizing power is high. Oxidizing power is high, and here that means my reducing power. This shows my reducing power. Right, so you just need to remember this thing here. Just remember this thing, and most of the questions based on reduction potential, this and that, you will be able to solve very, very, very easily. Right? More is the reduction potential, more is the oxidizing power, less is the reducing power. It would not want to get oxidized, but it would want to get reduced. Right? It would want to get reduced. Right? Okay. Now, let us see out of these two which has more standard electrode potential. Means they are talking about here it is gaining the electron, right? Here also it is gaining the electron. That means electrode potential means they are talking about reduction potential, right? They are talking about reduction potential, right? Here they are talking about reduction potential. So reduction potential of this is high. That means tin, that means Sn, it would want to get reduced. It would want to get reduced because here the reduction potential is high. If it is on the reduction side, then chromium will get oxidized. That means if it is doing the reduction, then that means here it is on the cathode side. And that means it is on the anode side. And our answer is E0 cathode. Cathode means we are talking about tin, right? Tin. minus E naught of anode, that means we are talking about chromium. In both the cases, they have given you reduction potential only. So just put it here. This is 0.5 minus and minus of 0.74. Right? Okay. And the answer will be 0.15, 0.74. It is 9.89. So answer is B is the correct answer. Okay? Yes. So answer is B is the correct answer. Tell me if that is clear or not. Right? So B will be the correct answer. Now tell me, student, is that clear or not? So here they have not given you directly. There is one more concept that you need to know, and that is this concept. Right? By the use of this concept, you can easily apply that and you will get your answer. Right? Okay, students, any problem here? Any problem here? Next is electrochemical series, right? As I told you, based on this thing, based on SHE, they have given us electrochemical series, which is arrangement of various half reaction in decreasing order of standard reduction potential. On the basis of the reduction potential values, we have this series, and you don't need to cram these values. They will be given to you in the question itself, right? So you don't need to cram any value here, right? So students try to mug up all these values. It's not possible, right? Okay. Yes, very good Abdul, Sukanya, Roshni, Philo, very good Sneha. Okay, now next is electrochemical series. This so I have already told you. You don't need to go through this again, right? I have already given you this simple chart here. This thing that I have told you here, right? It is an easy way of remembering things, right? I know theory is difficult to remember, but you can remember by this thing that it is directly proportional to oxidizing power, inversely to reducing power, right? Okay. Now let us do one more question based on this, a very, very important question again, right? That is your NEET 2019 question, a latest question, that is 2019. So it says that the standard electrode potential, right? Again, they have not mentioned, they are talking about reduction or oxidation, right? Standard electrode potential values of Al3 positive to An, from Ag positive to Ag, then we talk about K positive to K, then you talk about Cr3 positive to Cr, right? So tell me firstly in the chat box, they have given us all the values of reduction potential or the oxidation potential, or some of them are oxidation potential and some of them are reduction potential. Firstly tell me that thing. By that time I am writing the reduction potential. Okay. Yes, students. I just gave you the answer, right? Now, they are talking about the reduction potentials, right? So now, reduction potential means gain of electron again, gain of electron again, gain of electron again, gain of electron, or you can understand this by the oxidation number is decreasing in all these cases. That means they have given you reduction potential only. Reduction potential they have given you. It's not reducing power, reduction potential, right? They are asking you correct decreasing order of reducing power. Now tell me one thing, I have given you a direct relation that oxidation, no, I have given you direct relation between this, that your reduction potential is inversely proportional to reducing power, isn't it? Isn't it? Have I not given you this direct relation? That means if you write the order this here, that's the order of reducing power will be reversed, right? If I write the order here, this order will be, if I say this order will be, maximum is for Ag, that means minimum reducing power is for Ag. Minimum reducing power for Ag is in these two cases, so these two are eliminated, right? Minimum reduction potential is in which case? Minimum reduction potential is in this case. This is the minimum because this is this is negative in the number line, so this is the minimum reducing power, reduction potential. That means it is going to be the maximum reducing power. That means K is going to have the maximum reducing power. So answer will be C is the correct answer, right? C is the correct answer. So answer will become C is the correct answer. How come B? How come B? Aluminium is minus 1.66 and your potassium is minus 2.93. So potassium will have the least value of reducing potential, right? Reduction potential. That is why it will have the highest value of reducing power. So answer will be potassium here, right? That is C will be the correct answer. Okay? C will be the correct answer. Understood, Sukanya? Yes? Okay. Okay, everybody. Okay, everybody. Now moving towards some numericals, some formulas here, right? Now this formula, a very, very important formula, I'll tell you. Firstly, they have talked about work, that there are different types of work. We have already covered what is delta G. That is your Gibbs free energy. That is a work that is useful in nature. Useful work is called Gibbs energy. So now what is the relation between Gibbs free energy and electrode potential? The relation is delta G is equals to minus NFE cell, right? If you want to talk about standard Gibbs free energy, that will be delta G naught is equals to minus NFE naught cell, right? Okay. So now students, one very important thing to understand here, what is N? N is the number of electrons lost or gained. That means N is basically valency factor or N factor. Valency factor or N factor. Now tell me, have we studied about valency factor, N factor in detail in redox reactions? Yes, we have studied about valency factor, N factor in detail. That is why I told you that redox reaction forms a base of electrochemistry, right? Okay, so we will apply these two formulas whenever it is needed. So let us see some numerical based on this. This is for standard equation, right? Now, Gibbs free energy, and this is the example. Instead of example, we will just directly do the questions, right? Okay, this is again your NEET 2019 question. NEET 2019. Yes, what is given to us here? What is given to us here in this question? They have given us why there is so low strength. Huh? You guys don't want me to teach you or what? Or do you guys want me to rush the syllabus? Okay. Yes, everybody, do you want me to rush it or do you want me to teach you? Wait a minute. Let me ask the students. Because of Diwali is so like 2-3 days, it's over abhi. Those students who want to become a doctor, they are celebrating Diwali for what, 1 week or what, 10 days? Okay. Now, next is NEET 2019 question, right? So here it says that you have this reaction, right? In this E0 cell is given to you, standard Gibbs free energy of the cell is, right? So here what we want to calculate, right? We know the reaction, we know the formula is E delta G0 minus NF E0 cell. That means we need to calculate what is N. E0 is given to us. E0 is given to us, that is 0.04, 0.24, right? We just need to calculate what is N. Faraday is 96500. So for that, we will split this reaction into oxidation and reduction half cell. We know that This is Fe3 positive, that is getting converted to Fe2 positive. That means here oxidation number is going from +3 to +2. That means oxidation number is decreasing or increasing? It is decreasing, right? So that is your reduction part. So can I say Fe3 positive give rise to Fe2 positive, right? And here it is losing one electron or it is gaining, right? It is gaining one. In reduction, it is gaining one electron. From here, it is becoming Fe2 positive, right? That is at the cathode side. That is at the cathode side. And what about the anode side? In anode side, we have I negative is getting converted to I2 by losing electron, right? Here, because it is to I2, that is why it should also be 2I negative, right? So that means how many electrons should be lost? That is 2 electrons should be lost here, right? Then that means 2 electrons will be gained here, right? How come 2 electrons is possible? That means N is equals to 2. Wait a minute. Here they are saying that this is Fe3 positive, this is 6, right? 3 to 6, and this is 2 to 4. This is 6 and this is 4. Okay. Now, okay. So for 2 electrons, we need to have a difference of 2 also, right? So how come the difference can be there? If it is multiplied by 2, it is multiplied by 3. It is also multiplied by 2. Then we will have this as 3 into 2, that is +6, right? This is 2 into 2, that is +4. So by gaining 2 electron, it is getting converted to +4. And here it is -2. By losing 2 electrons, it is getting converted to 0, right? That means N is equals to going to be 2. So that means 2 electrons are getting lost and gained in this process. So then you just need to put the value of 2 here, F here and E0 cell, you will get your answer. And the answer will be like this. You just put the value of 2 minus 2, 96500.24 and you will get your answer. Here the option was in kilojoule. So here the answer will be in joules, right? The answer will be in joules because you have taken in this in volt, right? And this in your Faraday. So the answer will be in joules. And after that, you need to convert it into kilojoules, right? Okay, divided by 1000, you will convert it into kilojoules and that will be your answer, right? Okay, yes. The important part is not putting the values, right? The important part is understanding how many electrons are gained, how many electrons are lost, what is behaving as a cathode and which is behaving as an anode. So this is where people lag behind, right? Okay, yes, students. Yes, everyone, Roshni, Sneha, Disha, Sharath, we are here, ma'am. Very good, Sharath is here. Very nice. Okay. Now, next is Nernst equation. Now, Nernst equation is again a very important concept, right? Why? Because in you will see a lot of previous year question based on Nernst equation. Take out any competitive exam, right? That is incomplete without a Nernst equation, right? So now what we are going to study in Nernst equation. Firstly, what is the direct form of Nernst equation, right? I'll just tell you what is the form of Nernst equation, right? Okay, don't, yes. You don't even need to do this. Wait a minute. This is another question, right? Yeah, the PPT is little messed up, right? So let me write the Nernst equation myself only, right? So I'm writing it myself only, right? Okay? Yes. I'm writing it here. What is Nernst equation? What is Nernst equation and why it is used? Nernst equation. So Nernst equation is basically to find out the value of E cell. E0 cell, so we know that is how we will find out E0 cell, that is E0 cathode minus E0 anode. So now how to find out the value of E cell? Everybody in the chat box, how to find out the value of E cell, right? E cell is equals to, or chalo, I'll write it here only. E cell is equals to E naught cell minus RT. This is original definition, okay? This is original formula, right? You should also remember the original formula, but after that we will do a simple formula of this that you can use in numericals, right? Here you have RT by NF and natural log QC, right? But after, if you want to have any other temperature, then you can have different values. But if you are specifying that I have fixed the temperature, fixed the Faraday is also fixed, R is also fixed, right? So answer will be, or you can also write one more thing here. This will be E naught cell RT by NF. What is this? This QC. Can you tell me what is this QC? What is this QC? Have you studied equilibrium with me, right? We have studied equilibrium, right? In equilibrium, I told you about QC. What is this QC? QC is a reaction quotient. So what is this reaction quotient? This reaction quotient means you are talking about products divided by reactants, isn't it? The concentration of products divided by concentration of reactant, right? Isn't it? Products by reactant. Now, if I have to make a direct equation here, whenever I am talking about anything here, always I talk about that, for example, something is getting reduced, right? It is gaining electron, and it is getting reduced to this thing, right? Some other element is getting oxidized, it is getting converted to this thing. There is gain of electron, loss of electron. If I add these two equations, I will have A2 positive plus B, 2 will cancel out, and you will have B2 positive plus A. Isn't it? This will be the final equation everywhere in redox reaction. Most of the cases you will have this thing only, right? So guys, this was my cathode part, this was my anode part. That was my reduction part, that was my oxidation part. So that means whenever I am writing the reaction quotient, what exactly I am writing here? I am writing product by reactant. I know this is solid, this is also solid. For solid, we have studied this in equilibrium, that for a pure solid, the concentration we will take it as 1 only, right? So here that means we are not going to take the concentration of this A and B. We will only take this as B2 positive concentration divided by A2 positive concentration, right? Do you agree with all of this or not? Do you agree with all of this, right? So can I just directly write it as that? I can even write it as B2 positive is what? It is my concentration of that thing where oxidation is happening. So can I just write it here that this is basically my oxidation by reduction. So simply what you will do in the question, you will make definitely, because here you have N also. Whenever we are trying to calculate N, number of electrons, what we have to do? We have to make two equations. One is for cathode, one is for anode. One is for reduction and oxidation. You have to make two separate equations whenever you are using Nernst equation to calculate the number of electrons. So if you want to calculate the number of electrons, you have to make two equations. From those two equations only, you are going to put the oxidation. From the oxidation side, you will say this is the oxidation side, this is my ion. So this will be above, and here this is my A2 positive, this is in the denominator, numerator, okay? Simple, okay, right? So that is a simple method, right? Because as I told you in Nernst equation, the problem is not learning or to understand that where should I apply Nernst equation. The problem is understanding how to fill the values here. Ma'am, what I will fill in this QC, this is what you will fill in the QC, right? So here I am directly writing it as ln of oxidation by reduction. ln of oxidation by reduction, right? Now, there is one more thing. If I have fixed the temperature, if I solve this value, I can write it as E cell equals to E naught cell minus 0.59 divided by, wait a minute, that was 0.059, yeah, that was 0.059. 0.059 divided by n, because these three things I have already solved. That is my, one more thing we have done here. We have converted this natural log to log base 10. Because we know the values of log base 10, we don't know the value of natural log, right? So we have converted into log base 10. That is my oxidation by reduction. That means we have also multiplied this by 2.303. You can just directly write it as, you can write it as 2.303 RT by NF, and this is log base 10, or you don't need to write log base 10 again and again, oxidation by reduction. Okay, that will become your final equation, that is your Nernst equation. Now let us see how to apply this equation, right? That will become your final equation, right? Okay, so we'll do some question based on how to apply this equation, right everybody? Let us do one question based on this, right? Chalo. Okay. Now this is one more equation, right? Okay, so we will talk about this after after solving some question, right, based on Nernst equation. Now here this is 2019. In 2019, for a cell involving one electron, already they are giving involving one electron, means n is given to be 1. E0 cell is 0.59 volt at 598 Kelvin. E0 cell is also given to you, no issues. Then they have given you this also, equilibrium constant for the reaction. Now here they have given equilibrium constant. So firstly let us see that thing only, right? So basically how to calculate the equilibrium constant here, right? How to calculate the equilibrium constant. So for that you need to know this value, that is delta G is equals to delta G0 plus RT ln QC, right? Why this value? Because from this you will be able to understand that at equilibrium we have few conditions. And what is that condition? I told you in equilibrium only that there is one condition that is applied to Gibbs energy. And what is that condition? Everybody, it is also written on the board. What is that condition? We have studied this in equilibrium itself, that at equilibrium your not standard Gibbs energy. I am saying your Gibbs energy delta G is equals to 0 at equilibrium. QC, reaction quotient, will be equals to equilibrium constant, right? That is 𝐂𝐸𝐞, right? And now this and this may not be 0. This is not sure, right? So now we'll just put this value here, that your delta G is equals to 0. After putting this value, you will have delta G0 is equals to RT ln KQ, right? If you want to convert it into, log, you can even convert it into log. So this will become delta G0. This is the first equation, very, very important equation. That is delta G0 equals to minus RT natural log of KQ, right? Or if you want to solve this in the form of log base 10, you can write it as delta G0 equals to minus RT, or you can write minus 2.303 RT log base 10 Kc. This is a very, very important equation for your numericals, right? Very, very important equation for your numericals. Then next is, if you want to form a relation between E0 and KEQ, right? So that is, we know that delta G0 is equals to minus NF E0, that we have already studied, right? So minus NF E0 is equals to minus RT ln of this also you can write, or you can also write it as like this. I'll solve this on the next page only, because we don't have enough space to solve it. So we'll solve it on the next page only. We know that delta G0 that is equals to minus 2.303 0.303 RT log base 10 Kc, right, or KEQ, right? Now we know that this is equals to minus NF E naught of cell, E naught cell. So what we can write, 2.303, this minus minus, they will cancel out each other, log of Kc, right? So that means log of Kc, if you want to calculate, just want to write this formula, log of Kc is equals to NF E naught cell divided by, or you can just write the value of E naught cell. E naught cell is equals to 2.303. This is RT. This is my NF E naught cell. Just write NF log of Kc. Right? Okay. And the value of this thing you already know. The value of this thing you already know. E naught cell is equals to 0.059 divided by N log of Kc. This is your another formula, right? Okay. Okay, students. So this is another formula because we know that 2.303 RT by F, what is that? That is 0.059 only. So this is another important formula, right? Another important formula. If they are asking you Kc, they have given you Kc and they are asking you E naught cell, right? You can apply this formula, right? If they are asking you delta G naught, they have given you Kc, or they are asking you Kc, they have given you delta G naught, then you will apply this formula. These are the two important formulas, important relations, right? Okay. So here what they are giving us E naught and they are asking us to calculate the value of Kc. So basically this formula only you will apply. E naught cell is equals to 0.059. Here also they have given you 2.303 RT by F, right? So you already solve it as by N. This is log of Kc. N is 1 only. So E naught cell is given to be 0.59 and this is given to be 0.059, that is log Kc. So that means it will become equals to, this will be multiplied by 1000, this will multiply by 100, it will cancel out. So it will become log Kc equals to 10, right? So you'll have to take the anti-log here. You take the anti-log of anything, what it will be? You take the anti-log here. That means Kc is equals to anti-log of 10. What is the anti-log of a digit? That is 10 raised to power that thing. So it will be 10 raised to power 10. So answer will become 10 raised to power 10 means this will become the correct answer. D will become the correct answer, right? D will become the correct answer here. Right, students? Is that clear to everybody or not? Is that clear or not? Yes, everybody? Is that clear or not? Okay. Now, let us see based on this. Okay, there is one more important thing, right? That is conversion of energy. Let us talk about the conversion of energy firstly, right? Then we will go to the spontaneous, non-spontaneous reactions. Now here we are talking about the conversion of energy. What is conversion of energy? A very simple concept, yet a very asked concept. Conversion of energy. Conversion of energy. Now, if you talk about conversion of energy here, right? For example, they have given you a reaction. I am writing that reaction here. For example, they have given you A to A positive and then A positive to A2 positive, right? Here it is E1, here it is E2, here it is E1, here electrode potential is E0, E2, and to this side it is E3. Now, to this, if I say that you write E3 is equals to E1 plus E2, that is not the correct thing to write. What exactly they will ask you? They will give you, for example, they will give you E1, they will give you E2, they will ask you E3. Right? You can't just directly add the electrode potentials. It is non-additive in nature. It is non-additive in nature. You can't add the electrode potentials, right? This is a very, very important question, right? And you will see your previous year question, the latest 5 years trend, they are asking you the questions based on conversion of energy, right? Now, it is non-additive in nature. Now, ma'am, which thing is additive then? Your delta G is additive, right? So, delta G3 is equals to delta G1 plus delta G2. This is how you will solve the answer. How, ma'am? Delta G is what? That is minus NF. N will be different. This I am taking it as N3. For this reaction, I am taking it as N3. For this reaction, I am taking it as N1. For this reaction, I am taking the number of electron lost or gained as N2. Right? So, here it will be minus N3, Faraday is same. And this is E3. Right? This is E3. Here it is minus N1, Faraday is same, E1. Plus it is minus N2, Fe2. Minus, everywhere there will be minus. It will be cancelled. Right? So can I say here it will become as Faraday will also get cancelled here. Faraday will also get cancelled. Right? Because we will take Faraday common here. It will get cancelled. Can I say it will become N3 of E3 is equals to N1 E1 plus N2 E2. Right? So if they ask you anything, they ask you E1 from here, you can calculate. They ask you E3 from here, you can calculate. They ask you E2 from here, you can easily calculate. Right? Okay? Yes. Very good, Nancy. Standard Gibbs energy is your additive in nature. Right? Okay? So I'll just give you one question based on this. Right? I'll give you one question. Okay, let's talk about this question, that is copper. Right? Yes, I've not written not here, right? So write the not here. Standard conditions we are talking about here, right? This is not, right? Not, and not, right? So I'll give you one question. Let me see if in previous year question we have any questions based on that, right? Chalo. I think no question based on that. Okay, so I'll give you one question myself, right? So the question says that you have copper solid, plus you have, that is not the question. The question is, you have, let us say you have copper 2 positive plus 2 electrons, right? Plus 2 electrons that you have to calculate, right? Copper 2 positive plus 1 electron they are giving you. They have given you, this will convert to Cu positive, aqueous, right? And Cu positive plus 2 electron, it will get converted to copper. Now these are the 3 reactions. They have given you E0 of 0.15 and 0.50. This is given to be E0 is given to be 0.15 and this E0 is given to be 0.50, right? This E0 is given to be 0.50. Yes. They are asking you the E0 of Cu2 positive to Cu. Right? This is the question that is given to you. Right? This is the question that is given to you. Now, as if we firstly we need to draw a chart here. What is the chart that we need to draw here? The chart is, for example, they are saying that we have copper 2 positive. It will get converted to copper positive. Then copper positive is converted to copper. Right? So, if you talk about this first, Cu2 positive to Cu, they have given us it as 0.15, right? And the number of electrons, 1 electron is gained, so N is equals to 1 only, right? Here also we have seen that here N is equals to 1 only, number of electron is 1 only, and E0 is given to be 0.50. But in this case, N is equals to 2 because 2 electrons are getting gained. Here E0 we don't know. Here E0 is a question mark, right? So now we will calculate the value of E naught from this side. Right, now we will calculate the value of E naught here. Right, okay. Now we will calculate the value of E naught. Okay. So let's calculate the value of E naught here. Yes, everybody, how to calculate the value of E naught here? E naught, let us see what is E naught. As I told you, E naught has nothing to do with this one. You just have to calculate Gibbs energy. If I am taking it as 1, taking this as 2, taking this as 3, right? Taking this as 3. I know that what will be my answer. If I take this as 3, it will be N1, this will be N2, this will be my N3, right? Okay, this will be my E naught 1, this will be my E naught 2, and this is nothing but my E naught 3, right? So I can just write it here that delta G naught of 3 is equals to delta G naught of 1 plus delta G naught of 2, right? Minus will be cancelled, Faraday will be cancelled, so it will be N3 E3 is equals to N2 E2 plus N1 E1. They are asking you E3 here, that will be N2 E2 plus N1 E1 divided by N3, right? Divided by N3. Just put the naught here, right? Now, just put the values. N2 is what? 1. E2 is 0.50. N1 is again 1. E1 is 0.10, 0.15. N3 is what? 2. Right? Here you will be able to calculate what is your E naught 3. Right? What is your E naught 3? Okay, students? Yes, you can easily calculate that 0.65 divided by 2. It will be something 0.325. Right? Okay, 0.325. Okay, guys? Yes? Okay. Now, next is talking about the spontaneity and non-spontaneous reaction, right? So, based on Gibbs free energy, we talk about spontaneity and non-spontaneity of the reaction, and this question is also very, very important, right? This question is even more important when we talk about thermodynamics. In thermodynamics, I have taught you Gibbs-Helmholtz equation, right? There they talk about criteria of spontaneity a lot. So it is also related to that thing only, right? That your Gibbs free energy. Here we will talk about spontaneity in case of E naught and in case of Gibbs energy and in case of equilibrium constant, right? So we know that in spontaneous reaction which is occurring by itself, Gibbs free energy should be negative, right? Gibbs free energy should be negative. And what is the formula? Delta G is equals to minus NF E naught. Now tell me one thing, if this is a negative, this is minus, right? Then this should be positive. That means E naught cell will turn out to be positive. So that means in Gibbs free energy, we in a spontaneous reaction, we say that delta G is negative, but E naught cell is positive. But E naught cell is positive, right? But E naught cell is positive. Now there is one more equation, right? That I taught you here, that E naught cell, right? So let's talk about delta G only. Delta G naught is equals to RT minus RT ln Kc. Now students, tell me one thing. If I am saying that this thing is negative in nature, that means ln of Kc will be positive in nature. When log is positive, that means Kc is greater than 1. That means Kc is greater than 1. Log of the thing that are positive, right? Log of anything, if it comes out to be positive, that means that anything is greater than 1, right? Log of 1 is 0. If I am saying that ln Kc is 0, then my Kc will be is equals to, if I am saying my ln of Kc, yes, then my Kc will be equals to 1, right? Okay, these are the formulas of your log, right? Log, what it says, that if your ln of 1 is equals to 0. So for example, Any case I am saying ln Kc is equals to 0, that means Kc is equals to 1. So here if I am saying it is positive, that means Kc is greater than 1. Okay. So now that is why the third condition will become Kc is greater than 1. So these three conditions are very, very important conditions. Very, very important conditions. Okay. These three conditions are very, very important conditions. Here I have also told you why we have put these equations here. Right. Okay. Now they have given also this in table, right, that spontaneous reaction, first they are talking about E cell. If your delta G is positive, definitely your E cell will be negative because they have opposite signs. If this is negative, delta G is negative, that means they are talking about spontaneous reaction. So in spontaneous reaction, in thermodynamics, we have talked about delta G, we have talked about delta H, we have talked about delta S. We have talked about the criteria of spontaneity there also. Similarly, we are talking about the spontaneous reaction in case of delta G, E0 cell and Kc, right? So here this should be positive, this is positive, this should be negative, right? That means we are talking about non-spontaneous reaction. If delta G is 0, automatically E cell will be is equals to 0. If both are zeros, that means it is at equilibrium, right? We know that at equilibrium delta G is equals to 0. Right, here they are talking about Kc, right, here they are talking about Kc. Let us solve this question, and this is your 2011 question, right? Okay, if E0 cell for a given reaction has a negative value, they are saying that E0 cell is negative. They are asking the delta G value, right? See one thing, if E0 cell, I am taking it as negative. For delta G, I know that delta G0 is equals to minus NF E0 cell. If this is negative, then delta G will be positive. Delta G will be positive. And I know that if my delta G is positive, then you can directly write the equation also, or you can write it like this also, right? Or directly write the equation that E0 cell, or just write it here only, delta G is equals to minus RT ln Kc. If this is positive, that ln Kc should be negative. The log will come out to be negative only when the value inside the log is less than 1, right? So that means Kc is less than 1, right? So here they are denoting Kc by K equilibrium. So my delta G is positive, right? So these two options can't be correct, right? And my Kc is greater than 1. So B will become the correct answer, right? Sorry. Kc is negative. Yes, so my A will become the correct answer. A will become the correct answer, right? Okay, A will become the correct answer here. Next is electrolytic solution, right? Electrolytic solution. So we will do electrolytic solution after some time, right? We will take break now because we are left with electrolytic solution. Then you have electrolytic solution, how many different electrolytes you will have, right? What is the gas that will be eliminated at anode or cathode, these kind of things, right? Then you will have different batteries, primary batteries, secondary batteries, all of these theory part is left basically, right? Okay, and in electrolytic cell we will also talk about Faraday first law, Faraday second law. But before going, I think we have not done any question based on Nernst equation, is it? We have not done, right? We have not done any question based on Nernst equation. So I'll give you one question based on Nernst equation here, okay? Because we have not done any question based on Nernst equation, only then I will give you break. And then we will, then electrochemistry, that means electrochemical cell will be completed. After that, we will talk about electrolytic cell after the break, right? So let us do one question based on Nernst equation, right? You should also understand how to apply the Nernst equation, right? So let us do one question. I have one question, right? A very standard, very standard questions, right? In so many books you will see this. Cu2 positive to Cu, right? And then you have here equation, this is 0.1 molar, 0.01, and this is given to be 0.02, right? And here E0 of Zn E naught of Zn, Zn 2 positive, or this is given? Yeah, reduction is given for both, right? Reduction is given for both, right? 0.34, right? And this is given to be, reduction is given minus 0.34, and E naught of Cu2 positive, 2 copper, is given to be plus 0.76. See, they are asking you to calculate the value of E cell, right? So now, how to calculate the value of E cell? There are 2-3 parts to it, right? So we will divide it, right? So we will divide it, and we will calculate everything regarding that, right? So we'll divide the page. Now, firstly, let us see the Nernst equation. Nernst equation is E cell equals to E naught cell minus 0.059 divided by N log base 10 oxidation by reduction. So first you have to write where oxidation is happening, where reduction is happening. For that I want to write my 2 reactions, right? So 2 reactions. The first way is to firstly write 2 reactions, right? Oxidation and reduction. At anode what will happen? And then write at cathode what will happen, right? At anode what will happen? This is the anode part where Zn is getting converted to Zn2 positive, and here it is definitely losing the electrons, right? Now cathode, it is gaining the electron, here Cu2 positive, it is gaining 2 electrons and becoming Cu. We know that the electrons are already balanced here. That means we know N is equals to 2. So we know the value of N here, that N is equals to 2, right? N is equals to, that we already know. Now where you have oxidation, oxidation means this part, and this is your reduction part, right? So oxidation ion is going to be Zn. So we will write here Zn2 positive, and this is the concentration of reduction part, that is Cu2 positive, right? This is the oxidation of reduction part, that is Cu2 positive. Okay. Now, next thing is, if you write all the values here, so what is the value of E naught cell? E naught cell, we know that is equals to, E naught cell is equals to E naught of cathode. Cathode is this thing. That means reduction potential of Zn we need, that is given to be minus 0.34. How I can say reduction potential is given? Because here it is gaining the electron, plus 2 to 0. Plus 2 to 0. In both cases, it is reduction potential only that is mentioned. In both the cases, reduction potential is mentioned, right? Now, this is my cathode minus anode. This is, it will not be, E naught is equal to E naught, cathode minus anode. We need cathode firstly, right? Cathode is this thing. So, we will write the electrode potential of copper firstly. So, it will be 0.76 minus of anode. Anode is your zinc, right? And zinc is what? Minus 0.34. So your answer will be 0.76 plus 0.34 plus 0.34. It will become 0, right? Then 7, 8, 9, 10, 1. Wait a minute. 7, 6, 3, 4, 7, 8, 9, 10, 11. 1.1, right? Yes. 1.1. Daniell cell only, no? Yeah. E naught of Daniell cell, 1.1 only. Right? Daniell cell is given to us. So directly we would know that it is 1.1. Right? So now this is, yes. The E naught is 1.1. Yes. So now here E naught cell is coming out to be 1.1, 0.059 divided by N is 2. Log, what is Zn2 positive? Concentration is 0.01, and here the concentration, okay, this should also be multiplied by the stoichiometric powers, right? So in the full reaction there is no stoichiometry, it will be 0.01, right? And it will be 0.02, this will cancel and this will be 1 by 2. What is 1 by 2, right? Can I say this is basically 1.1 minus 0.059. What is 1 by 2? It will be log 2 inverse. This minus can come to this side and it will become positive 59. What is log 2? That is 0.301. and you just need to calculate this. That will be your E cell. That will be your E cell. Right? Let's see after calculating what you are getting. After calculating what you are getting. Yes. 1.1 approx. Here approximation will not work, right? Because you have to tell the little amount that is added here, right? So it will turn out to be 1.109 volt, right? Because originally it is 1.1. So you have to tell that what is the amount that is added here, right? Okay, understood guys? So that is how you should apply Nernst equation. And one more thing about Nernst equation. Here it was very simple, that nothing you have to do here. For example, they have given you a question which is A3 positive. It is getting converted to A by gaining 3 electrons. And B is getting converted to B2 positive after losing 2 electrons. Now, ma'am, which will be my N? Ma'am, should I take 2 as N or 3 as N? As I have told you, number of electrons gained and lost should be same. Right? Okay. Yes. 1.1089. Very good. Now, here it is 3 electrons are gaining, 3 electrons it is gaining, 2 electrons it is losing. So, it will be multiplied by 2 here. It will be multiplied by 3 here. And this will become A3 positive, that is 2A3 positive plus 6 electrons will give rise to 2A. And this is 3B give rise to 3B positive, 3B2 positive plus 6 electrons. Then it will cancel out. Here you will say N is equals to 6, right? Here you will say that N will become equals to 6. Now you know what is the next important thing here? Yes ma'am, N is equals to 6. That is important. But now the reaction quotient will also change. Reaction quotient will be equals to oxidation and reduction. We know that this is your cathode part, this is anode part, right? So we know at anode you have oxidation. So instead of writing just B2 positive, it will be raised to power the stoichiometry. Divided by, instead of writing just A3 positive, it will be A3 positive raised to power the stoichiometry, right? So this was a simple question. But they can give you these kind of questions as well. And I won't say these are complicated, right? This though they can definitely give you in NEET, right? Right? You are going to become doctor after this, right? So you should know at least these kind of questions, how to solve them, right? Now the main important part is how to find out the value of N, right? That is by multiplication. Then don't ignore the final equation, because final equation will become 3A positive plus 3B give rise to 3, wait a minute, this is 3A positive, this 3B plus, this is, wait a minute, 2 positive, this is 2A. Now we know that the ions are this one and this one. So they will be raised to the power of the stoichiometry. Okay? Okay, ji. Understood? Now, I think all the complications I have already told you. Now we are left with electrolytic cell, right? Electrolytic, and don't ignore electrolytic cell. It is usually ignored by many of you, right? We have Faraday's law. Questions are asked based on that. There are 2 laws. We have how to answer that in electrolytic cell. At a node what you will have, at cathode what you will have, and you have specific electrolytes only, right? We will talk about those electrolytes, right? Very, very important that is. Then the third part is we will talk about this batteries, primary and secondary batteries. Okay? Understood? So now I am going to give you break for 15 minutes, right? 15 minutes break I am going to give you. After 15 minutes, we are going to talk about electrolytic cell, right? Okay. So here the time is 8:15. I'll see you at 8:30, right? So I'm writing it here. The class is going to resume at 8:30 p.m. Okay. So see you all at 8:30 p.m. for the rest of the chapter, right? Let's complete the chapter today itself. Okay, then see you all. Okay, guys, I am back. Am I audible? Am I visible, everybody? Am I audible? Am I visible, everybody in the chat box? How many of you had your dinner? Or you're still waiting for me to end the class and then you will have your dinner? Yes, let me inform the other kids as well that the break is over. Okay. Okay. Now, we are going to talk about electrolytic solution, right? Okay. We are going to talk about electrolytic solution now. Now, basically, electrolytic solution, we all know that we will give it electricity, right? Firstly, what is electrolytic solution? Very small topics you will have in electrolytic solution, right? Now, this is electrolytic solution. Here, basically, what will happen? What will happen when you give the electricity? Electrical energy will be converted to chemical reactions. They will produce some chemical reactions in that. That is your electrolytic solution, right? That is what your electrolytic solution, right? So, in electrolytic solution, right, we will talk about so many things. Firstly, we will talk about different types of electrolytes, right? Examples, I would say, examples that at anode and cathode, what will be produced. Then we will discuss Faraday's law, right? Faraday's law. And one more concept that is not basically of electrolytic cell, but that is conductance, right? These concepts are still, we have not done them. Then you have one more concept that is Faraday's law, that is based on electrolytic cell, right? So these are the four things. So right, Wheatstone bridge is not in your syllabus, right? Like it is not in chemistry, right? Okay, just a little part. Now, firstly, let us talk about the conductance, okay? Firstly, we will talk about the conductance. That is going to be our first topic. Then we will talk about Faraday's law, or then we will talk about examples. Then we will talk about Faraday's law. Wait a minute. Then we will talk about examples. Then basically this example is called product of electrolysis, right? They will ask you the product of electrolysis here, right? A good name is better to write, right? So firstly, we will talk about conductance, conductivities, the formulas, molar conductance, molar conductivity, all of that. Then we will talk about product of electrolysis, right? That is our second topic. Third topic is going to be Faraday's law, first and second law. And last, we are going to talk about batteries. Batteries, primary, secondary batteries. That is going to be our fourth topic here, right? Okay, these four topics we need to complete in this lecture, right? Okay, yes. Now, let us talk about conductance firstly. So, there are four things that you need to understand. First is, ma'am, what is resistance? Second is, what is conductance? Then what is resistivity? What is resistivity? What is conductivity? What are the symbols? That also, right? Then we'll jump to the formulas, right? So firstly, resistance is to resist something. That means to oppose the flow of current. That is called resistance. Conductance is opposite of resistance, right? That means how much current is flowing, right? Like Nancy has written in the chat box that ease in flow of current is called the conductance, right? Now, resistance is mentioned by capital R, right? Resistance is mentioned by capital R. Conductance is represented by capital G, right? Or in some books you will see it as capital C, right? But I'll say remember this at capital G. Resistivity, that is represented by this snake kind of thing, that is called rho, right? That is called rho. right? So now what is resistivity and what is conductivity? Conductivity, let us represent this by, conductivity is represented by, yeah, kappa, right? This thing is called rho, this is called kappa. These are the four things that you need to remember, the symbols. And what does this mean? Now ma'am, what is the difference between resistance and resistivity? Ma'am, what is the difference between conductance and conductivity? Resistance is basically, we are talking about one, for example, any wire or any cube, any beaker. In physics, you will talk about wires. In chemistry, we will talk about conductivity. We will talk about beakers, right? The solution, right? So I am taking here, for example, we are talking about a cube. Resistance means I am talking about resistance throughout this length, breadth and height, right? Throughout this V volume, I am talking about the resistance. How much resistance is there in this particular volume? But when I am talking about a unit volume, for example, I am just talking about which has this part, which is having length 1, breadth 1 and height also 1. If the unit volume I am talking about, then that is called resistivity. If I am talking about unit volume solution, and I want to see how much conductivity is present in this unit volume, then I am talking about conductivity. If I am talking about how much conductivity is present in this whole solution, then I am talking about conductance. Okay? So that was the difference between resistance, conductance, conductivity, resistivity. Right? Okay, students. So that is the difference between conductance, resistance, resistivity. Right? Now, a very important 2-3 formulas we have. R is equals to rho L by A. I'll tell you just 2-3 formulas only. G is equals to G star is equals to kappa. Now, ma'am, what is this G star? This G star is called as cell constant, and that is nothing but it is L by A, length by area, right? So now let us see why these two formulas are important for you, because all the other formulas are generated from these two formulas only. That's why I am saying that you just need to learn these two formulas. If you know these two formulas, you are sorted already, right? You just need to know these two formulas. Why? Ma'am, okay, this is R is called resistance, rho is resistivity. Ma'am, now I want to have a formula between conductance and conductivity. Now this will become 1 by G. This is L by A only, right? What is rho? That will become 1 by kappa, right? 1 by K, that is conductivity, right? Now, this L by A is called G star, this 1 by K and this is 1 by G. So if you multiply this here, this will become G star into G and this will become kappa, that is nothing but this thing, right? So these are the two formulas that are mostly used, right? These are the two important formulas that are mostly used in your numericals, right? From this you can calculate anything. They ask you conductivity, you just write it 1 by kappa. You can calculate conductivity. They ask you conductance, you just write 1 by G, that is your conductance. They ask you cell constant here. Put the value of conductance in kappa, you will get the cell constant, right? So these are the two formulas that are used in conductance and conductivity. Is that clear to everybody or not? Yes, students, is that clear or not? Now, wait a minute. Yes. Let us talk about the units here. Units I have not written, right? So let us talk about the units. If you talk about units, this is called ohm, right? This is per ohm, or this is called Simon, right? This is called resistivity. Resistivity is what? Resistivity will be equals to R into A by L. Resistance is ohm. This is meter square. If this is meter, so it will be meter will be cancel out. It will become ohm per meter. If that is in centimeter, it will become ohm per centimeter, right? If the length and area is in centimeter, right? If you talk about conductivity, that is opposite of resistivity. So it will become per ohm meter, or it will become per ohm centimeter, right? So that will be the units. Okay, so that will be the units. Okay, students, that will be the units. Okay. Okay, students, that will be the units. Now let us talk about other things, right? That was about resistance, conductance, resistivity, conductivity, right? Now, if you talk about molar conductivity, what is molar conductivity? That is represented by this. What is equivalent conductivity? That is represented by this. Now, what is molar conductivity and what is equivalent conductivity, right? Molar conductivity, basically we are defining, wait a minute. So many things are defined here, right? Oy hoy. So many things. Chalo, I'll talk about myself only, like I'll talk about in simple language only, right? So this is your molar conductivity. Molar conductivity is basically your conductivity for 1 mole, right? 1 molar solution. So it will be kappa into 1000 multiplied by molarity. And if you talk about equivalent conductivity is kappa into 1000 multiplied divided by equivalent, right? This is basically normality, right? Normality. Because for equivalent conductivity, we are talking about normality. For molar conductivity, we are talking about molarity, right? Okay, so just write these two formulas here. Just write these two formulas here. And what is the significance of these two formulas? And when can you apply these formulas? That is also important, right? Why? Because these two formulas, that is kappa into 1000 divided by molarity. Now here the important thing is, there are specific units for this kappa. This kappa should be equals to only centimeter, right? That means this kappa should be equals to ohm, wait a minute, that is, yes, that is equals to per ohm centimeter, not meter, right? I have given you choice here, no, that it can be in meters on centimeter, length or breadth, height can be in meters on centimeters. But if you want to apply this formula, then you have to write per ohm centimeter, or you can say Simon centimeter. That's it. Okay, that is the condition here. Okay, okay, due to 1 mole ion or electrolyte. Very good. So that is the important thing for solving the numericals. That is the important thing for solving the numericals. And the next thing is, rarely they will ask you equivalent conductivity, but still I am writing it here, right? In equivalent conductivity is equals to kappa into 1000 divided by normality. Again here you will write that your kappa should be in per ohm centimeter. Only then you can apply this formula. If you are applying meter here, then you will use kappa by normality into 1000, and here you will use kappa by molarity into 1000. So that's why I am saying always convert it into centimeter only, right? Don't fall into this thing, right? Okay, but still if you want to write this thing here, I will write it here. If you want to write this thing here, let's write it here. This is for per ohm, right? Wait a minute. This should be kappa multiplied by this, and here it is kappa multiplied by normality. Here just mention one thing, that your kappa should be in per ohm. Kappa should be in per ohm. Just write it here, that kappa should be in per ohm centimeter. Now write one more formula. This is equals to kappa by molarity into 1000, and equivalent conductivity is equals to kappa by normality into 1000, and this formula is applied only when your kappa is in per ohm meter, right? Okay, so these are the two important things. You have to see the units also. Don't ignore the units like that. Okay, understood? Simple. Everybody in the chat box, is it simple? Yes. Okay. Now let us see what is given in the theory part. Firstly, so they are talking about here. Firstly, so they are talking about electron conductance, this conductance, that conductance. So I'll give my own short notes to you, right? In a simple way, we will understand all these things, right? Okay. Chalo, just give me a minute. Yes. Chalo. Now we will see, because I think in this way it is much better than just copy pasting thing from PPTs. I try to ignore it as much as possible, right? So now we will talk about firstly two things, right? Two things important, that is your metallic conductivity and electrical conductivity. The question that they can ask you. One is metallic conductivity, that means conductivity in metals, and there is electrolytic conductivity in electrolytic solutions, right? What is the difference? The first difference is that in metals, the flow of electrons is responsible for conductivity. So here we talk about flow of electrons, right? Here we talk about flow of electrons. But in electrolytic conductivity, we talk about flow of which thing? We talk about flow of which thing? We talk about electrolytes. Electrolytes will break into ions, right? We talk about chemicals, ions, right? So flow of ions is responsible for your electrical conductivity, right? Okay. In this case, simply you will have a metal. There will be electrons. There will be kernels, and there will be electrons, right? And they are vibrating. They are moving here and there. There is no chemical reaction that is involved. No chemical reaction. No chemical reaction is involved. But in electrolytic conductance, when electricity is due to the ions we are talking about, in that case, definitely there is chemical reaction. Definitely there is chemical reaction. There will be reduction. There will be oxidation. Because of that, we are saying there is conductivity, right? Then next thing is, there is no transfer of matter. No transfer of matter. Here we are saying it's just the electrons, the kernels are staying at their own place, right? The copper atom, we are talking about copper atom, copper rod. Here the copper atom is going to stay on its own place. The electrons are vibrating, right? And the atoms are only vibrating. The electrons are moving here and there, right? So basically there is no as such matter that we are exchanging. There is no mass that we are exchanging, right? But in this case, as chemical reaction is happening, that is why, because of ions have mass, electron mass is negligible, right? So there is transfer of matter in this case. There is transfer of matter in this case. Now last important is effect of temperature. Effect of temperature, and here also effect of temperature. Effect of temperature. I'll just tell you this is actually opposite to each other. Now tell me one thing. When you talk about metals, the more temperature you will provide, the kinetic energy will increase or decrease. Yes, everybody? If you talk about this is your, here, remember one thing, here metal atoms are placed in a restricted manner, right? Here you have, these are your atoms. These are your atoms. These are atoms, right? Now you have increased the temperature. For example, in this room, I have 100 students. They are just standing like this. They don't have space to stand, right? It's just like this Diljit Dosanjh concert. There's no space to stand, right? So for example, you have gone to a big party, right? So there is no space for you to stand, right? In Diwali also, when you go to markets, there was no space to stand, right? Now, in Diwali, you went to the market, you are enjoying in the market and you are like, oh my God, what a beautiful this and that. Suddenly someone said that there is fire in this market. Now what will happen, right? There was also this case that there was some bhajan or something like that was going on, right? Some religious ceremony was going on, right? Then what happened? Suddenly there was, I think, fire or maybe something was happening, right? Some sort of thing happened there, and the crowd was literally, the crowd crossed like on the people who are lying there on the floor. Some of them fell down and the other people were crossing on those people, right? So basically it's the same thing, right? So here atoms are very in a congested manner, right? So in a congested manner, when you increase the temperature, their kinetic energy will increase. Then you will think, ma'am, conductivity will increase, right? But exactly what will happen? Because space is really less. That is why they will have the energy, but they will not have the space to move. That is why, because of that thing, they will collide with each other, and that is the reason their conductivity will decrease. And this is a very, very important thing, right? So when you increase the temperature, conductivity decreases. But when we talk about electrolytic conductivity, there is no as such restriction, right? This is your beaker, right? Here you have solution, right? When you increase the temperature, for example, I have NaCl. Earlier I am saying 100 out of 100, 50 molecules were under dissociation. But now I am saying after increasing the temperature, 80 molecules are under dissociation. That means number of ions increased in the solution. That means conductivity will increase in the solution. So you will just directly write temperature increases, so conductivity will increase in the solution, right? Conductivity will increase in the solution. Yes, kernels start vibrating and hinder the movement of the electron, right? Okay, understood? Because of so many restrictions there, right? Okay, so that was about metallic and electrical conductivity. Now let us talk about what is dilution, right? What is the effect of dilution? This is also very, very important conceptual question, right? Very, very, very important, right? We will see the effect of dilution on conductance, on conductivity, on molar conductivity. These are the three things mainly that we will talk about, right? Okay. Okay. Chalo. Now, firstly, let us talk about dilution. When you increase the dilution means adding water. For example, you have a beaker, you are adding water into it, adding water. That means you are decreasing the concentration of that solution, right? Concentration of that solution that you are decreasing. So whenever they say dilution is increasing, concentration is decreasing. Concentration is decreasing. If my dilution is increasing, concentration is decreasing. So can I say dilution increases, concentration decreases? Now, firstly, let us talk about, ma'am, what will be the answer for conductivity, right? What will be the answer for conductivity? Conductivity. Will that increase or will that decrease? So, conductivity we talk about, which thing we talk about? Per unit volume, right? So, you have a beaker. Here we are talking about per unit volume. Per unit volume we are talking about means this volume we are talking about, right? This much volume we are talking about, only this volume, not this full beaker, right? We are not talking about this full beaker. So, conductivity means we are talking about per unit volume, right? In that unit volume, number of ions will define the conductivity. More the number of ions, more will be the conductivity. Now you have added water. I am zooming this in. Okay, I am zooming this in. I am zooming this in. It will become something like this. Zooming this in, this cube I am zooming in, where we are discussing the conductivity. Earlier I am saying that earlier you had 1 molecule, 2 molecule, 3 molecule, 4 molecule. These are chalo ions. These are the ions that you had, right? These are the ions that you had in 1 unit cube, 1 unit per unit volume, right? In 1 unit volume, right? Now, after dilution, once you are adding water into it, then what will happen? Some of the space water molecule will occupy. Some of the space water molecule will occupy or not, right? So I am writing water molecule as pink, right? These are my water molecules. So in some of the space water molecule will be present now. So because of that, these ions will have less space, right? These ions will have less space, right? That is why in that unit volume, here you had 1, 2, 3, 4, 5, 6, 7, 8, 9. Here you have 1, 2, 3, 4, 5, 6, 7, 8. Right? Still I have drawn 8. So let's make 1 minus. Right? Because here if I want to draw, I can even draw more. If I want to complete that much space. Right? I can even draw this much. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Here it is 1, 2, 3, 4, 5, 6, 7. That means because of the addition of water, for example, you are living in your home, right? You are like very chilling in your home. You are like, okay, I have my full room, right? Suddenly guests appear in your house. Then what your mama will say? What your parents will say? They will say, can you please sleep in the drawing room today? Why, mama? Because guests are coming. So we need one room free. So that means the guest is this H2O, right? Dilution, you are diluting it. So when you are diluting it, you have to move out of your room. And we are calculating your presence in that room. We are not calculating your presence in the house. You will stay in the house. Whether you are in drawing room, you will stay in the house. Similarly, these other molecules are in the solution only, but they are not in that 1 unit cube. So that means in this unit cube, your concentration, the concentration of ions will decrease. If the concentration of ions will decrease, can I say kappa will decrease? That means conductivity will decrease. Tell me, students. Can I say kappa will decrease, conductivity will decrease? Now, students, tell me, is that clear to everybody or not? Right? Is that clear to everybody or not? Yes? Electrolytic conductance or conductivity? If you talk about conductance, you are talking about per unit. You are talking about full copper length. For example, this is copper wire. If you are talking about conductance, you can write anything there, right? That is the condition for both of them. If you write here conductance also, that is the same thing. Right? If you write conductivity, that is the same thing. Because for conductance, we are talking about this full length. Right? For conductivity, we are only talking about some like that unit volume. Right? Okay? Yes. Now, let us talk about the next thing, that is with the dilution. What will happen to, with the dilution, what will happen to molar conductivity? We know that with dilution, concentration will decrease. Now, molar conductivity, what will happen to this? Molar conductivity, it is not something you can say that molar conductivity, we are talking about unit volume. We have specified that we are talking about 1 molar solution, right? We have specified that thing, that we are talking about 1 molar solution. So, basically, it will depend on which thing. This is kappa into 1000 divided by this molarity, right? Okay. If you talk about the concentration, concentration is in which thing? Concentration is measured in which thing? Molarity. So can I just write here, if concentration decreases, molarity decreases. Molarity decreases. Right? This is the formula base that I am telling you. Right? Molarity decreases. If molarity will decrease, that means molar conductivity will increase. That is why on dilution, molar conductivity, or you can just directly write this molar conductivity is going to increase. Right? On dilution, this will happen. Or you can just write it here. Molar conductivity increases. Right? So these are the two things. Right? Reason here is that we are just specified to that 1 mole. If this is your 1 mole, I am specified to that. Now my main focus is not on the volume, how many ions are there. No, it's number of ions. I am not focused on that thing. Now which thing will define my number of ions? Which thing will define? Concentration will define the number of ions. As concentration is decreasing in that 1 molar solution, if in 1 molar solution concentration I am saying it is decreasing, that means molar conductivity will increase. So right, so that is the difference between this kappa and molar conductivity. Now students, tell me, is that clear to everybody or not? Is that clear to everybody or not? Is that clear to everybody or not? Now write one more thing. This is applicable for, this is for strong and weak electrolytes. This is for both. This is for both. Right? This is applicable for both strong and weak electrolytes. Right? This is, we know that when dilution increases, concentration decreases and conductivity will decrease, whether you talk about strong electrolytes or you talk about weak electrolytes. But when we talk about this thing, here it is applicable, it is different from strong electrolytes and different for weak electrolytes. Right? So let us write it here. What is the difference of strong electrolytes and weak electrolytes? Right? Chalo. Let us write down the difference of strong electrolytes and weak electrolytes that we will see at infinite dilution. We know that at infinite dilution, that is called infinite molar conductivity. It is represented by this thing, right? Limiting molar conductivity it is called. It is called limiting molar conductivity. Limiting molar conductivity, right? It is called limiting molar conductivity. Now we will see how it is different for strong electrolyte, how it is different for weak electrolyte. That we can see at infinite dilution, right? This is at infinite dilution only. We can see that what is the difference here. Why it is different? Why this molar conductivity is different, right? So this is for strong electrolyte. This is for strong electrolyte. And this is for weak electrolyte. And then we will also have a law for weak electrolyte, right? For strong electrolyte, if you draw a graph here, now they will draw a graph here. This is your graph, right? And the graph is between limiting molar the graph is between concentration and molar conductivity, right? And I will write one formula based on this. You can just ignore this formula. You can also, if you want to remember this, you can remember this as well. Minus, right? Okay. So that becomes your equation, right? Now, for strong electrolyte, we know that is equals to Y is equals to the same thing that we did for chemical kinetics. Y is equals to, this is equals to mx plus c. So this c becomes intercept. Slope is negative. So it will be like this. It will be minus a is the slope. Slope is minus a. Intercept is limiting molar conductivity. And this x is your c under root. That becomes your x. That is a graph. Now, that means, can I say that this is a graph? Now, is this verified? I am saying we are increasing the dilution. That means we are decreasing the concentration. Now, from the concept, we know that when we decrease the concentration, right, our molar conductivity will increase, right? When I am decreasing the concentration, molar conductivity is increasing. And at infinite dilution, my molar conductivity will become this. right? That is limiting molar conductivity, right? Now, yes, because it is fully dissociated, right? Because strong electrolyte is fully dissociated, that is why I can have that on the y-axis, I can have that intercept, right? Okay, but this is not there in case of weak electrolyte. It is not so. Why? In case of weak electrolyte, same graph if we draw, wait a minute, right? So it will come to something like this. We are decreasing it. It will go, wait a minute, it will go parallel to a y-axis. Wait a minute. Let me just extend this y-axis here, right? It will go parallel to the y-axis. It will firstly increase. Firstly, what will happen, a weak electrolyte, it is not having 100% dissociation. Slowly the ions will dissociate because it is a weak electrolyte. So it's not like suddenly it will increase to same constant, right? First it will try like I don't want to increase and increase, and it is like then it will become parallel to y-axis. At one point it will become parallel to y-axis, right? There is no intercept, right? So we can't calculate the value of limiting molar conductivity from any graph or from any equation, right? Like from this equation we can calculate the value of limiting molar conductivity, but in weak electrolytes the reason is like CH3COH, right? This is a weak electrolyte. I know if I have 100 molecules, maybe out of this 30 molecules will dissociate, right? Then if I start diluting it, no doubt the conductivity will increase, right? But it will increase slowly. Then again gradually it will increase to that extent that it will become parallel to y-axis only. So there is no graph that we can draw here, right? There is no graph where we can find that what is the conductivity when there is complete dissociation, right? What will happen at when we have a zero concentration at infinite dilution, what will happen, right? So because of this, we have this law that is called Kohlrausch law. Kohlrausch, spelling may be wrong, right? Kohlrausch law, right? So this Kohlrausch law, what is this Kohlrausch law? Everybody in the chat box. Everybody in the chat box. Everybody in the chat box. Let us see what will happen here, right? So Kohlrausch law says that if you talk about the molar conductivity, he is saying that if you talk about a weak electrolyte, that is, let us say CH3COH, a weak electrolyte, right? Weak electrolyte. He is saying that the molar conductivity of that compound, that electrolyte at infinite dilution is equals to the ions, the individual ions, the cations and anions. That means they are saying that it is the sum of individual ions, right, raised to the power of the stoichiometry coefficients, right? For example, I am talking about MgOH twice, right? So for this case, limiting molar conductivity will be equals to molar conductivity of Mg2 positive plus molar conductivity of OH negative, and this will be, sorry, it's not raised to the power, it will be multiplied by stoichiometry, right? So it will be multiplied. So it will be multiplied by the stoichiometry. Why? Because MgOH twice, the ions it will give is Mg2 positive plus OH negative, and that is 2. That is why limiting molar conductivity of Mg2 positive plus 2 into limiting molar conductivity of OH negative, right? This will become the answer. Now students, tell me, is that clear? What is Kohlrausch law, right? That is called a very, very simple law, right? So this is actually a very, 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 very simple law. Okay? Okay? Okay, students? Yes. Now, a question that is it's not basically mentioned in your NCERT. It is a table that is given in your NCERT, right? From that we can have this formula, not this formula, this relation. First, let me write it correctly. So it's 2OH negative, right? These are the examples. These are the examples. Now, let us see one more thing about this. That is, if the size of an ion is large, then the limiting molar conductivity will be high. For example, I am talking about Na positive, then you have Ca2 positive, or you can say Li positive. Now sodium and lithium, Li na ki, right? Li na ki, Ruby say friendship, right? So that means down the group size increases. That means we know that sodium has more size as compared to lithium. That means delta, why I'm saying delta, limiting molar conductivity of Na positive will be greater than limiting molar conductivity of Li positive, right? Okay. Okay, students. Yes. Okay, students. Okay, everybody. Now, but here write one more thing. There is exception of hydrogen. Hydrogen to hydrogen, this will not be applied, right? To other atoms, this will be applied. For example, you have a question that is given to you is Cl negative and Br negative, right? Which will have more limiting molar conductivity. Because bromine, we know that it is having bigger size, so it will have more limiting molar conductivity. If they are saying Ca2 positive plus Mg2 positive, which will have more limiting molar conductivity. Yes, students, which will have more limiting molar conductivity. Beta mange car. That means MgCa. Calcium has more mass, that is why it will have more limiting molar conductivity. Right? Okay, students? Yes, everybody. Right? So this though all of you can do, but this is usually students ignore this. That is why I have written it here. Right? Because we need to be prepared for everything. Right? Okay? Any chances to change in NEET UG? Shreya sir has already made a video on that, right? Okay, in detail we have covered this thing, right? The confusion that is for NEET 2025, right? Okay, now next is, okay, this also we have done. There is one more question that they can ask you. They can ask you degree of dissociation, right? They can ask you degree of dissociation. Degree of dissociation. Now, what is degree of dissociation? Alpha, ma'am, it is the degree of dissociation. But with degree of dissociation, you need to know one thing. That degree of dissociation, alpha, right? How to calculate that? For example, you have a formula. This I have told you in ionic equilibrium, right? How to calculate specific formula everywhere, right? So, if you have this electrolyte, right, which is a monobasic electrolyte, a monobasic acid if you have, then you will use this thing, right? So here this is initially it was 0, C it was 0, 0. Then C minus C alpha, this is C alpha, this is C alpha. So Ka will become, right, that is your dissociation constant. You can just write K, yeah, A only you can write. So this will become products, that is C alpha, that is C alpha square. Now this will become C minus C alpha. I will take C as common, right? So this will be C square, CC will cancel each other. C alpha square, 1 minus alpha. Now, as degree of dissociation for weak electrolyte means it is not able to dissociate to that much extent. So that means alpha is very, very less than 1. That is why 1 minus alpha, we can write it as 1 only. So answer will become that Ka, that means dissociation constant is equals to C alpha square. So now if they ask you dissociation constant, that you can calculate, ma'am, but this is the question of equilibrium. why you are putting it here. Ma'am, what is the reason you are putting it here? Right? Okay. What is the reason, ma'am, you are putting it here? So, what they will give you, how they will twist the question here, right? Not even twist, I would say. It's just a lengthy question, right? Just a lengthy question. More calculation will be there, right? So, alpha is equals to, in terms of molar conductivity, alpha is equals to molar conductivity at concentration C divided by molar conductivity at infinite dilution, right? So now this will be calculated by this thing, kappa into 1000 by molarity. They will give you molarity, they will give you conductivity. You will calculate molar conductivity from that, right? Right? You will calculate molar conductivity at concentration C from that. And this will be calculated by Kohlrausch law, right? Kohlrausch law. This you will calculate by Kohlrausch law, or they will give you directly the infinite molar conductivity, right? Okay. Now, with Kohlrausch law also some students have little bit problems that, ma'am, how to do. I to find this very, very simple, right? And students also, they will feel like, ma'am, this is the simplest thing. Now you have three equations, right? CH3COOH, it will give rise to CH3COOH, COO negative plus H positive. Then you have CH3, not CH3, then you have HCl, that is a strong electrolyte, it is H positive, Cl negative. Then you have to cancel this C. Wait a minute. Wait a minute. What should I have? If I have H here, then I should have one H and the C will be cancelled here, right? Then I should also have something which is having CH3COONA, right? Then I should also have something where Na should be cancelled out. If I have here Na, right? Wait a minute. Right? This is HCl, this is NaCl. This is Na positive plus this is Cl negative. Right? Now, these three things, yes. I think now it's right. Now, for example, this is the question that is given to you. And they are asking you for CH3, COOH. This is the electrolyte that you need to answer, right? Now, you need to cancel, you need to have just CH3COO negative and you need to have just S positive. These two things you need to have. That means this I need to have and this I need to have. I want to cancel these two things. I want to cancel these two things. If I am taking this as 1, this as 2, this as 3. So, can I say that limiting molar conductivity of CH3COOH is equals to, I will add this thing, I will subtract this thing and I will add first and 2. Basically what I will do, I will add 1 and 2, add 1 plus 2 and subtract 3 from it. Then you will get the answer as CH3COO, because here what will happen, right? CC will cancel each other and you will have, in the end, you will have which thing? You will have CH3COOH, which will be basically this thing. Wait a minute. When you add these two things, right, what you will have? You will be left with CH3CO negative and H positive. This will cancel out with this one. This will cancel out with this one, because here you will have minus minus and it will cancel out. So that means what you will have in the end, you will have limiting molar conductivity of CH3COO negative plus limiting molar conductivity of H positive. You want to have this. For that, what you will write, instead of writing this, you will write limiting, because in the question they will give you limiting molar conductivity of this, this and this, right? So instead of this, you will write limiting molar conductivity of CH3COONA plus limiting molar conductivity of HCl minus limiting molar conductivity of NaCl, right? So what I did, I just thought that what I should cancel so that I can have these two ions in the end. I should add these two things and subtract this thing. The same I did here. I added these molar conductivity of first two and subtracted the third one from there, right? Only then I can have this thing, right? And this is what is Kohlrausch law, right? Okay, this is the application of Kohlrausch law. Okay, students, that is the application of Kohlrausch law, right? Okay, everybody. Now, Kohlrausch law also we have done, degree of dissociation we have done, right? Then you can also calculate dissociation constant from there, right? Now, this also we have done. Everything, ma'am, we have done. Yes. Kohlrausch law, application, this part. Chal. Now, let us do the question here. The question says that you have following limiting molar conductivity. Oh my God, I think my lecture will go really long today. It's a big chapter, yeah, what to do? I don't want to skip anything, right? That's why. So this is 2019 question. Following limiting molar conductivities are given as. So molar conductivities of H2SO4 is given to you, right? K2SO4 is given to you and CH3COOK is given to you. Same thing. H2SO4 will give us 2H positive plus SO4 2 negative. K2SO4 will give us 2K positive plus SO4 2 negative. And CH3COK will give us CH3COO negative plus K positive. Now see one thing, what you need to have, right? I want to have this thing in the end and H positive, any one H positive in the end, right? So H positive is present here. That means I will have to multiply this by half. And if I want to cancel this K positive with this 2K positive, so I will also have to multiply this by half, right? Now I know that the conductivity of this is given to be, first is given to be X. So it will be X by 2. Here it is given to be Y. So it will be Y by 2. Here it is given to be Z, right? Here it is given to be Z. Now, the result will be, if I take this as 1, this as 2, this as my third. So what I will do, I will add 1 and 2 and I will subtract third from I will add first one and third one. That is my first one, this is second and this is third. So I will have to add this and this, right? I will have to add this and this. See here what it will become. Okay, I'll tell you in the next page only. The first one will become, it will be H positive plus SO4 2 negative divided by 2. This will become K positive plus SO4 2 negative divided by 2. And the third one will become CH3COO negative plus K positive. This will become X by 2, this is Y by 2 and this is Z, right? So I know if I have to make this equation as CH3COOH, then I need to have this thing and this thing. So what I will do, I will add X by 2 plus Z, then it will become equals to Y. Then I'll have to subtract Y by 2 from there. That will be my final answer for limiting molar conductivity of CH3COOH, right? So it will become X minus Y by 2 plus Z, right? Okay. Thank you, beta. Thank you. So it will become X minus Y by 2 plus Z, right? So what exactly we did here? What exactly we did here? You can even add these two. Add these two, what you will have? You'll have CH3CO plus K positive plus H positive SO4. You will subtract, this will cancel out, this will cancel out by this one, right? Okay. Okay, so I'll write it here for you. right? So basically what we are doing, I am saying this is first, this is second equation, this is third equation, right? Now what I am doing, I am adding 1 and third, I am adding 1 and third, and I am subtracting second from it. If you add 1 and third, it will be H positive plus SO4, 2 negative divided by 2. Third is CH3, COO negative plus K positive. We will subtract second from it, that is K positive minus SO4, 2 negative by 2. This will cancel out, this will cancel out, you will be left with CH3CO and H positive. What is needed, right? This is the same thing that is needed, okay? This is the same thing that is needed. Okay guys, everybody in the chat box, is that clear or not? Is that clear or not? Raish, I would advise you, try to solve it yourself, right, after the class. Why I am saying that? To you may think that, ma'am, I don't know what you are doing here, right? But when you will solve this, you'll be like, that was so easy, ma'am, right? Okay. So try to solve it yourself after the class. I can guarantee that you will be able to solve this, right? It's just that you are getting confused that, ma'am, what you are doing, right? So when you will solve it yourself, it will become really easy for you, because this is nothing but this is maths only, right? Okay. What's your name? Raish, I have done nothing, yeah, nothing. What I have done here. So, if you want me to elaborate this more, this is, wait a minute, I'll copy paste this thing. This was H2SO4 give rise to 2H positive plus SO4 2 negative, right? Then you had K2SO4 give rise to 2K positive plus SO4 2 negative, right? Then you had CH3 COOK give rise to CH3 COO negative plus K positive, right? They are asking me find out for CH3 COOH. For that I need CH3 COO, this one, and I need H positive. For H positive I will divide it by 2. So it will be, so the answer will be this. I will divide it by 2. Here, my limiting molar conductivity is X, this is Y, and this is Z. When I divide it by 2, it will become 1 by 2, it will become 1 by 2, 1 by 2, that is, it will become 1, and it will become this. Here also I need to divide it by 2, it will become 1, and it will become divided by 2, it will become this, right? So that is why limiting molar conductivity will also change, right? Now I told you that this is 1, this is 2, this is 3. I need to preserve this thing and this thing. That is only possible. The things that I need to keep, I will add those two equations. That means I will add first and third. The thing that I don't need in my final equation, I will just subtract it, right? I will just subtract it, right? Now this will become that I have already done here, right? This thing I have already done here, right? This thing I have already done here. Then what you will do, this is H positive. Here you have H positive plus SO4, 2 negative by 2, CH3 CO negative plus K positive, and here you will be only left with H positive and CH3 COO negative, right? And hence what you will write, this will be 1 plus 3 minus 2, that is 1 is what X by Y, 3 is what Z, minus 2 is what Y by 2, right? So if you solve this, this will become X minus Y by 2 plus Z, okay? 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 Understood or not? Yes, everybody. Yes, everybody. Tell me if you are able to understand this or not. I think I wasted my time on solve. This is that is why some YouTube teachers ignore kids here, because when you give them attention, when you try to give them attention, say my name. What will happen if I say your name? Right? Will you get Ambani's whole property, or what you will get? If that is so, I will say. Right? So now electrolytic cells. Right? Now let us talk about electrolytic cells. Right? So in electrolytic cell, now we are left with three topics, right? Important topics, right? Electrochemical cell in which non-spontaneous reaction is forced to occur by passing a direct current from external source. So this is your electrolytic cell. Here what exactly we are doing? This is firstly in only one beaker, right? This is firstly in only one beaker. Here you have anode and cathode, but here anode is positive. Anode is positive in this case. Cathode is negative, right? Cathode is negative. So anode is connected to the positive terminal of the battery, right? Anode is connected to the positive terminal of the battery. This is anode and this is cathode, right? And this is cathode. Now what will happen? We know that the electrons will flow in which direction? From positive to negative direction. In this direction the electrons will flow, right? The current will flow in this direction from positive to negative. That we have done. Nancy, right? Now we have the current is in which direction? Anode to cathode, right? Okay. Now, yeah, this Raesh, he just made me realize that, ma'am, you should not focus on the kids who are asking for please repeat this, please repeat this. I am not able to understand, because these kids are here to ask, hi Tanuja, hi Nancy, how are you? What's your Instagram ID? Seriously, because of you kids, some of the kids who genuinely have questions, they are ignored because of you guys, right? Because teachers are like, maybe this kid is also like some other kid out there who just wants to disturb the class, right? Now I am feeling sad for myself that I explained that again. I wrote that page again for this kid, right? So yes. Now, guys, in the chat box, electrolytic cell, right? So electrolytic cell is basically, I just want to, because I don't want any distractions right now, right? So I would like to block someone here. I would want to block someone here. I'm not able to. Okay, wait a minute. Okay. Chal. Now, let us see this class, right? Now, what is electrolytic cell? Where electricity is converted into chemical energy. Chemical reactions will be produced here, right? So, based on this particular equation, let us see what is happening here, right? Let us see what exactly is happening here in this particular situation, right? So, now you have two things. You have two electrodes here, right? Two electrodes, one is cathode and other is anode. Now everybody tell me what will happen at anode. This will stay as it is, that at anode oxidation will occur, right? That means here you will have one electrode. If you talk about both are copper electrode. So at anode, copper electrode is going to lose the electrons. But at cathode, copper electron is going to gain the electron and become copper, right? Copper electrode is going to lose the electron and become Cu2 positive. But at anode, there will be gain of electron. So copper electron is going to gain the electron and become Copper. Ma'am, what is the use of this thing? This is used for the purification processes. How this is used for purification is a very important concept, right? This is used for purification processes. How it is used for purification processes, understand this. In purification, what exactly happens? It's like when you are purifying your shirt, what you are doing? You are just removing the dust here, right? So what we do here, we take anode as the impure metal, right? And we take cathode as, in cathode we are taking the pure metal, right? Pure electrode we are taking of same thing. So if your electrode, if your cathode and anode are same, what will happen here? Now we are talking about only purification processes. When cathode and anode is same, anode is taken as impure, and how purification will happen, right? So see, based on these reactions only, at anode what will happen? This is anode, this what will happen? Here, because of the oxidation, it will lose electrons and it will get converted to copper 2 positive ions. So you will have these copper 2 positive ion will move into the solution, and some of the impurities, if I draw the impurities by this dot dot, the impurities will be in this anode mud. They will settle down here in the anode mud. It's like when you are dusting off the extra impurities on your shirt. What you're doing? You're just removing it like this. Same thing is with anode. Now, earlier you had atom, right? Now it is removing this, in this rod it is removing impurities also. It is removing electrons also. It is removing Cu2 positive ions also. Cu2 positive ions will go into the solution. Electrons will move in this direction. That is why the electron flow is like in this direction, right? Because at anode, electrons will be removed, right? And then there is 2 electrons that will be gone here. And what about the impurities in that electron? So it's like the same thing when you want to break something, when you want to break this thing, right? So the impurities over here will also be dusted off, right? Because I am breaking this thing. Whenever, for example, this is the rod, I am breaking this rod. So the impurities that are present here will also be dusted off, right? So in the end, what will happen? The anode will have, the thickness of anode will decrease here, right? The thickness of anode will decrease here. And what about at cathode side? The 2 electrons that will come to this side, copper ions present in the solution, they are going to gain those 2 electrons and they will become copper, and this will become your pure electrode. This will get settled on the pure electrode, and hence here the thickness will increase. Here the thickness will increase, right? Like this, the thickness will increase here. Like the thickness will increase here. This is what will happen. Here thickness will increase, here thickness will decrease, right? Understood this point or not? Right, so that is called the purification. Impure copper is made as anode and that is at cathode. That is how we purify sodium, magnesium, aluminium, right? Next is electrolysis. Now this is basically the product of electrolysis that I was talking about, right? The product of electrolysis. The reactions that I'll be mentioning here are very important for you, right? And yes, sometimes you also have to cram things here, right? So let us see basically on which method they are based on, right? So now, when you talk about electrolysis of molten NaCl, in molten NaCl you will not have any competition. That means you will not have any water here. Here what will happen? You will have only 2 ions, that is Na positive and Cl negative. We know that always cation is going to, see, before electrolytic, before product of electrolysis, you should understand one thing, right? Before doing product of electrolysis, you should understand one thing, that which will product of electrolysis, right? You should understand one thing, that which is going to get in cathode side, right? So at cathode side, definitely there is gain of electrons. So the cation is going to take part, right? At anode side, you will mostly see anion, right? You will see anions. It is most of the cases you will see this thing, right? Okay, especially in the product. It's not always you will see this. I am saying in most of the cases you will see this, right? So now this is giving us Na positive and Cl negative. Now we know that Na positive is going to take part in which thing, right? Yes, Cl gas will be evolved at anode. Very good. So now Na positive, there is no competition because it is molten, there is no water in it, right? So definitely Na positive is going to act at cathode side, is going to gain the electron and become sodium, right? And Cl negative is going to lose the electron and become Cl2. So definitely you can say that at anode you will have Cl2 gas and at cathode you will have sodium deposited, right? So this will be asked to you that in the electrolysis of NaCl, what is at anode and what is at cathode, right? It's not like you have to do for all the things that are in the, like in this universe, electrolysis of all the compounds. You just have to do what I am telling you, right? Now next is, that is for one only, is it? No other product of electrolysis are given. Wait a minute, if that is there, it is here, right? So it is here, product of electrolysis. So let us see that. For that you need to understand one more thing, right? Now in molten NaCl there was no competition, but if they talk about aqueous NaCl, we know that in aqueous NaCl there will be competition, because in aqueous NaCl what you will have? In aqueous NaCl you will, from NaCl you will have Na positive and Cl negative. From H2O you will have H positive and OH negative, right? So that means you will have different ions here. So there is a competition, right? In this competition, who will win? Here you have these two competition, here you have competition between these two things, right? So who will win and when who will win, right? So this you have to learn, right? So let us talk about who will win here, right? So now we are talking about product of electrolysis. They are saying A, for example, its electrode potential is -2, B is having electrode potential -1.5 and C is having electrode potential as -1. So electrode potential of A is less, then there is B, and maximum is for electrode potential of C, right? Maximum is electrode potential of C. But we can see that the same is the electrode potential, same is the order of cations to get discharged. That means this they are talking about at cathode. At cathode, more is the reduction potential, more is the capability to take part in the reaction. So out of Na positive and H positive, Na positive and H positive, which will have more reduction potential, that will take part in the cathode reaction. Okay, that will take part in the cathode reaction. Is that clear? Is that clear? Which will have more electrode potential, right? So we can say that when more than one ion compete to discharge at an electrode, the ion will discharge first, which has maximum electrode potential. But this they are talking about at cathode, right? Okay. Now let us talk about at anode. This will be opposite, right? Yes, this is the over potential they are talking about, right? I think NaCl so we have already done. This is in case of aqueous, this I was talking about, right? So let us talk about the case of aqueous NaCl. Now, before this, there is also one more thing that you need to understand, right? There is also one more thing that you need to understand, right? I am going to write it here only, right? That is for water, right? Wait a minute. Firstly, just write down the conclusion part. Selectivity, discharge selectivity, you can say. Just write down this conclusion part here, that at cathode, more maximum reduction potential, it will get discharged. At anode, which will have maximum oxidation potential or minimum reduction potential, right? That is the first thing that you need to remember when you are talking about product of electrolysis, right? When we are talking about product of electrolysis, this is the first thing that we need to remember, right? Okay. 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 This is the first condition. This is the first condition. Second condition is for electrolytes. For electrodes. That is the first condition. Second is inert electrode. Whenever you will see inert electrodes, what are the inert electrodes? Like platinum, right? They will not participate, right? But non-inert, you can say active, right? Active electrodes, like the electrode of its own self, right? That will participate. We will see that in the different questions, right? That will participate, right? That is going to participate, right? Okay, right? Okay, everybody. Now, third thing that is also very important. Here I am going to talk about water in oxidation. Water in oxidation, because usually that is not mentioned, and water under reduction. Water under reduction. Water under oxidation, it is going to give us O2. Water under reduction, it is going to give us H2. Right? I am just directly writing. What is the value of E0 here? E0 value are different here, right? E0 values are different. That is why it will depend if you are using water as it is taking part in oxidation or it is taking part in reduction, right? So here it is minus 1.23 and here it is minus 0.83, right? Now I'll tell you what is the reason that I am telling you all of this thing, right? This you will get to know when I am solving the questions, okay? Okay, everybody? Okay, everybody? To this also you can write because of overpotential, right? Because of overpotential, you will add minus 0.3, that is overpotential, it will become 1.46, right? Okay, chal. Now, let us do one by one. We are going to do how many cases? 7-8 cases we are going to do, right? 7-8 cases, let's do that. And you never know which will be asked to you, right? So let us do. Now I think it will be easy for you to understand, right? So now the first question is, in case of aqueous NaCl. In case of aqueous NaCl, as you know that you have four things. You have Na positive, you have Cl negative, you have H positive, you have OH negative, right? You have these four things, right? Basically, you have water here, right? You have these four things. Now you need to understand which will take part and which will not take part, right? Okay. Yes, students, everybody in the chat box. Here they have done it in different manner. I want you to do it in different manner. Do you want me to write only? Wait a minute. I wanted that because whenever I write too much, my board will start blinking, right? I have talked to the team. They are exchanging the board in a week. So for 1 week, I want to be very cautious that I should not write that much on the board. So I am thinking that should I just write down the reactions or should I proceed with these reactions only that are mentioned here? What to do? What do you think? Chalo, let us do this only. Okay. Now, here you have four reactions, four things. One is Na positive and one is Cl negative and OH negative. Now see, at cathode, two things can happen. One is Na positive, other is H positive. Two things can happen. If you talk about Na positive, it is having an electrode potential of minus 2.71. If you talk about H positive, after gaining the electrons, it is having an electrode potential of 0. So as we can see, the electrode potential 0 is more. That is why we will select H positive here. If you talk about Cl negative and OH negative, right? Cl negative and OH negative. Now at anode you will have these two reactions, right? That means at anode you will have Cl negative, which is having electrode potential of 1.36. And if you talk about water, if it is behaving as is in oxidation, now water in oxidation, how it is behaving? When water is getting oxidized, it is giving us O2, right? It is giving us O2. That is 1.23, right? That I have written here as well, right? That I have written 1.23. Wait a minute. That should be minus 1.23, right? E0. Okay, we have written E0 of reduction potential. I have written reduction potential here. Here they are talking about oxidation potential. They are writing oxidation potential, right? They are writing oxidation potential. Which has more oxidation potential? Everybody, which has more oxidation potential? This will have more oxidation. And these two, they are mentioning oxidation potential, not reduction potential, right? Because reduction potential, if you want to write, this will be minus, right? So reduction potential of which thing is less, that will be oxidized. This is having less reduction potential, so that will be oxidized. If you want to write oxidation potential, this is the oxidation potential. More is the oxidation potential, it will be oxidized. That means Cl2 will be formed. So in the net reaction, you will have Cl2, you will have H2, and the remaining Na positive and OH negative, they will form NaOH, right? Okay. Okay guys. So I would advise you, the way I do it, right? The way I do it is not this, right? Rather, I would advise you to write it in this way, right? To write it in this way, that here it should not be H positive, rather it should be, because the same reaction that I told you, no? H positive, the reduction potential of H positive. When water is under reduction, it is giving us H2, right? And here E0 is equals to minus 0.83, right? Now, which is more? Minus 0.83 is more. That is why this will be selected. That is why H positive is selected, right? And at anode, what you had? At anode, you had these two things. At anode, what you have? You have these two things. That is why, which will having more oxidation potential, that will be selected. That is why which thing will be selected? This will be selected. That is Cl2 is selected. That is why we can see at anode, what will happen? Cl2. At cathode, you will have H2. Right? This is for aqueous NaCl. Right? This is for aqueous NaCl. Right? Guys, I do want to, I'll just take the name of God and I'll just write myself only, because I'm not finding it good. Whenever I see the PPTs, I get sad. Okay? So, that's why I'm waiting for my board to come so that I can write on board freely. Right? So now let us see, the second case, write the case, that is CuSO4 aqueous solution, right? CuSO4 aqueous solution. In CuSO4 aqueous solution, there are 2-3 things, right? In CuSO4 aqueous solution, you have CuSO4, and CuSO4 means you will have Cu2 positive, you will have SO4 negative, you will have aqueous solution means H positive and OH negative, right? So there are two cases, one is at anode, other is at cathode. So at anode, what will happen? Two cases can happen at anode. At anode, you can have Cu2 positive, that is going to gain 2 electrons and become Cu, or you can have H2O, that can give you H2, right? And at anode, two things can happen. At anode, what are the two things that can happen? At anode you will have, sorry, at cathode what you will have? This will be cathode. Right? This will be cathode, this will be anode. This will be cathode and this will be anode. At anode what can happen? You will have SO4 2 negative and you have OH negative, right? So SO4 2 negative, that can give you SO2, right? And this OH negative, right? That means water at anode will give you O2, right? So this is the main thing that can happen. Is it? This is S2O8 2 negative. I am not writing the full-fledged reactions here. I am just writing the E values, right? Why I am writing the E values? It's not like in the exam you have to remember the E values. You can't. That's not possible, right? I just want you to know that how we are selecting the products, right? Okay. So copper will have, they will give you that copper will have this much value. Now this will have minus 1.23, right? And this will have, wait a minute, so minus 1.23, no, this will have reduction, na, 0.83. Here it will have minus 1.23 and here SO4 will have minus 2.01. This they will give you in the question, right? They will give you in the question if they ask you something different, but the cases that I am giving you here, they can ask you directly, right? 7-8 cases that are there in your syllabus that I am asking you, right? So now here just these are the reduction potentials that I am mentioning here. All of them are reduction potential only. High reduction potential is going to give us what? Cathode side. That means copper is deposited at cathode side, and low reduction potential is required at this case, right? That means this one. That means this one, right? Okay. Low reduction potential we require. Yeah, wait a minute. They have given you oxidation or reduction. This is reduction potential. This is reduction potential. This is oxidation potential. This is oxidation potential. Yes. So yes, in case of reduction potential, you need high. In case of oxidation potential, you need low, right? Oxidation potential should also be high, right? So which oxidation potential is high? That will get to oxidize itself, right? Oxidation potential of this one is high, so O2 will be liberated. So answer will be at cathode you will have copper, but at anode you will have O2, right? Okay. Now the flow will increase, right? Then the third case is going to be aqueous Na2SO4, right? So in this solution, you have H positive, you have OH negative, you have Na positive, you have SO4 2 negative. So again, what I will write here, I'll just copy paste this thing here, okay? I'll just copy paste this thing here, and instead of SuSO4, I will write here aqueous, right? Because rest of the things are same only. So it is aqueous Na2SO4, right? So instead of Cu, I have Na, right? Instead of Cu, you have Na positive. So for Na positive, what is your reduction potential? It will gain 1 electron and it will get converted to Na, right? What is the reduction potential here? What is the reduction potential of sodium? That is minus 2.71 volt. Now you have to select according to the same criteria that I told you. For water, reduction potential is minus 0.83. For this is minus 2.71, which has more reduction potential. This has more reduction potential. Out of this, which has more oxidation potential? This will have more oxidation potential. So at cathode here, you will write here that H2 will be liberated, right? That H2 will be liberated, right, students? Okay. Now the fourth part is aqueous solution of CuSO4. Now aqueous solution of CuSO4, but the condition is only these 4-5 cases they will ask you. condition is copper electrode you are using. That means you are not using inert electrode. If nothing is mentioned, that means inert electrode only they are talking about. Now here copper will also take part in the reaction, right? So this is cathode and this is anode, and this is anode. At cathode you will have Cu2 positive, right? You will have water, right? And at anode what you will have? Anode you will have Cu, you will have SO4, 2 negative, that is going to lose the electrons. It is also going to lose the electrons, and you will have water. So these are the three things that you will have. It will get converted to Cu, it will get converted to H2, it will get converted to Cu2 positive after losing the electrons, it will get converted to S2O8 2 negative, and it will get converted to O2 on oxidation, right? Here we will write the E0 of reduction potential, that will be given to you. That is experimental thing, right? Or you just have to remember in the end what you will have in all these cases, right? So this is minus 0.83 volt. This is minus 1.23 volt, right? Here oxidation potential was mentioned here only, right? It was minus 2.01 volt. This is new to us, right? For copper we have 0.34, right? And this is opposite of that, so it is minus 0.34 volt. Now tell me which will be at cathode and which will be at anode, right? How long it will take? I don't know. I will complete the chapter today, right? Now tell me what you will have. I could have just told you that this is the product of electrolysis, do the examples yourself, right? But I am writing everything here. Reason being, I don't want to compromise on the quality, right? So now tell me, students. Now I think abhi to you will be able to understand what we are doing, right? We need a high reduction potential. That is there in this case. That means copper will be deposited, and here we need high oxidation potential. Highest oxidation potential is for again this one. That means again you will have which thing? Again this will happen. Again copper ions will be there, and here copper will be deposited. Isn't it same like purification? Isn't it same like purification? Right? Isn't it same like purification? Yes, everyone. So this is used for refining, right? This is used for refining. The same case that we did in the starting, right? Here so many things are given to you, CuSO4, Cu. So what exactly we are doing here? It is purification process, right? It is a process of purification only, right? Now next case, this is first case done, second, third, right? This is the third case, right? Fourth done. Fifth case is if you have aqueous H2SO4. Now what will happen? Now you will have H positive and SO4 2 negative. From water also you will have H positive and OH negative. So at cathode, so it is simple. At cathode it's not a big deal. At cathode eventually you are going to have water, H2 only. At cathode you will have H2 only, because water also it will give you H2. H positive will also give you H2. So you're going to have water only, right? H2 only. At anode, let us see what is the case. At anode, what you have? You have SO4 2 negative. Now I'm not writing it again and again, right? So let me write. This E0 is what? I think that was 0.01 volt, hai na? So now about water, when it is giving you oxidation O2, it is E0 is equals to 1.23, right? 1.23 volt, right? Now tell me which is high. Now tell me, students, which is high? Students, which is high? Which is high? Which oxidation potential is more? Definitely this oxidation potential is more, right? This oxidation potential is more. On the number line, see na negative values. So on the number line, you will see that this is having more. And here, answer will be H2, right? So here H2 and O2 will be produced, right? Okay. Okay. They can also ask you from which case the anode is produced. From water or from H positive from the acid. So if you take H positive from the acid, here electrode potential is, reduction potential is 0 because this is nothing but SHE, standard hydrogen potential. But when we talk about water, when water will give us H2, it will have reduction potential as minus 0.83. So definitely here H2 is liberated, but that is H positive is from acid, not from water, right? Okay. Okay, students. Now two more cases we have. Next is I think you will be able to answer this. Aqueous solution of AgNO3. Aqueous solution of AgNO3. Yes, students, aqueous solution of AgNO3. Yes, aqueous solution of AgNO3. So at cathode, what you will have? At cathode, you will definitely have cations, that is Ag positive to Ag. Then you will have aqueous solution. Because of that, you will have water, which will give you H2. Then at anode, you will have NO3 negative, which will give you NO2, right? And then you will have a water that will give you O2, right? Okay, right? Wait a minute, this is not possible only. Why I have written it here? Yeah. So this NO3, why this is not possible? Can you firstly tell me? This is also a question of your, I think, PYQ only. Why this is not possible? Here, oxidation is not possible because X minus 6 is equals to minus 1. X is equals to, in which case, this is 6 minus 1, that is 5, right? So that is already in the highest oxidation state. Highest nitrogen can have, like, this is already in highest oxidation state. It cannot extend from 5, right? So that is why there is no oxidation of this. No oxidation possible. No oxidation possible. So in this case, you will have O2 only. But what about Ag here? What about Ag here? Ag is E0, reduction potential is 0.8. And here E0 of reduction potential is going to be minus 0.83, right? So here which is more? This one is more. So Ag will be deposited and you will have which thing? O2, right? Okay. Now, for example, in the next case, something different is given. That means, in the next case, they have given you with the Ag electrode. With Ag electrode means, this Ag electrode will always do, like if you are talking about electrode, they will do oxidation. They will lose the electrons, right? So, it will be converted into Ag positive. That is nothing but it is electrode oxidation potential will be equals to minus 0.8. And here the oxidation potential is equals to minus 1.23, which is having more oxidation potential. Definitely this is having more oxidation potential. That means in the cathode part you will have depositation, in the cathode part silver will be deposited. But in the anode part, this will fail now, right? This will not happen. This will not happen, right? Rather, this thing will happen. That means Ag will give off ions. That means at cathode, you are depositing silver. At anode, silver is getting dissolved. Isn't it the same as purification? Isn't it same as purification, right? So this method is also used for purification, right? This method is also used for purification. Okay, students. So these are some of the important cases here, right? Okay, everybody, understood? Understood? Ma'am, please do not tell more, I am about to cry. Now firstly tell me, are you able to understand this or not? Now ma'am, what I need to remember here, right? So I'll tell you what you need to remember here. In all these cases, what you need to remember, you don't need to remember these values. You just need to remember who will win here. You just need to remember this thing here. You just need to remember that when you talk about copper sulfate solution, cathode and at anode, you will have O2. When you will have aqueous copper sulfate solution with copper, then you will have, at cathode you will have copper, at anode you will have, again copper will win, right? Now, if you have aqueous Na2SO4, H2 at cathode and anode, you will have O2, right? Then if you talk about aqueous H2SO4, you will have H2 at cathode, O2 at anode. For aqueous AgNO3, Ag at cathode, then you will have O2 at anode. For with Ag electrode, you will have purification thing, that is Ag at cathode, then Ag is dissolved at anode. Okay? Yes, it's just in the end you have to remember this thing. If you want to understand how this happened, you can remember the value of this H2O, you can remember the value of this one. Others, if they ask you any anonymous question, right, then they will give you the values of reduction potential. For that, you have to remember this thing here, right, this chart that I have given you here. In the first way that I have told you, that you have to remember this thing here, right, that cathode means maximum reduction potential, anode means maximum oxidation potential or minimum reduction potential, and inert electrodes will not take part, active electrodes will take part in the reaction. H2O oxidation, it will give you O2, that is approximately 1 point, this is your reduction potential, not oxidation potential, this is also your reduction potential, right? Here I have not written oxidation potential. Oxidation potential is, here oxidation potential is minus 1.23. Here, no doubt, after over voltage, you will have, in reality, you have 1.46. But when we are solving the question of product of electrolysis, we will take it as minus 1.23 only. Right? Okay? Understood? Wait a minute. No. Here, oxidation potential, that will be minus 1.43. Right? Now this is oxidation potential I have written, here I have written reduction potential, right? And that was about product of electrolysis. That was a major topic that I was scared about. Then how I will complete this topic in this chapter, in this class. Now we are just left with a very small topic, right? A very small topic. Let's finish that off. Now, on electrolysis of dilute sulfuric acid, if you have dilute sulfuric acid using platinum, that is inert electrode, dilute sulfuric acid is a NEET 2020 question, right? So, you have H2SO4, right? That will give you H positive, right? So, definitely add what will be the product that will be obtained at anode. Anode means SO4 2 negative and you will have H2, right? So, H2 will have minus 1.23, right, and this will have minus 2.01, I think, yes, right. So it will have, which will have less, which will have, this is a oxidation potential, no, yes, which will have more oxidation potential, this one or this one, this will have more oxidation potential. So that means it will, in oxidation, it will liberate O2. So answer will be oxygen gas is the correct answer. Okay, oxygen gas is the correct answer. That is your NEET 2020 question. Okay, so don't ignore product of electrolysis. It is a very ignored topic. Students just do Nernst equation. Okay, ma'am, we know electrochemistry, right? They just skip these kind of topics, right? So don't skip these kind of topics. Now, next is concentration cell, right? Have you skipped Faraday by any chance? Yes, we have skipped Faraday. Where was Faraday? It was here. It was here, right? So we have basically two laws of Faraday, right? Two laws of Faraday. So I'll just write it here. Two laws of Faraday. Chalo, I'll just write it here. Faraday's first law of electrolysis. Faraday's first law of electrolysis, it says that the amount of chemical reaction which occurs at any electrode during electrolysis by current is proportional to the quantity of electricity that is passed through the electrolyte. That means weight is directly proportional to the electricity, right? Now we will see after this what will be the formula that we will have, right? So the formula is going to be, wait a minute, I'll just write the formula. This is weight, M means weight only. M is equals to ZIT, where Z is called the, not the proportionality constant, this is called electrochemical equivalent of substance, right? Basically, it's a proportionality constant. Yes. Now, this I is current and T is your time, right? So now let us write down the full-fledged formula here, right? I am not again liking this. I'll delete this only, right? Chalo. I am writing this myself only, right? Okay. So, let us write the first law of Faraday. Just dividing this into two parts. First law of Faraday. Faraday first law. Here also questions are asked. Faraday first law, and then there is Faraday's second law. Faraday's second law. Faraday's second law. So if you talk about Faraday's first law, what is Faraday's first law? That is equals to weight deposited is equals to ZIT, right? Where Z is the equivalent constant, like electrochemical equivalence, right? Okay. So what is electrochemical equivalence? That is equals to molar mass. Weight is equals to molar mass divided by NF, right, into I into T. I is the current here, right? This is a full-fledged formula, or you can also write it as equivalent mass divided by Faraday multiplied by I into T, right? Or you can just replace these two things here, right? And that is going to be the final answer, right? So whenever they will ask you a question, you will just need to put the value, right? And you will get your answer. They will ask you the weight of copper deposited, right? What is the molar mass of copper? How many electrons it has gained? Faraday's 96500. What is the current that is passed? What is the time that they have given you? You will apply this formula. You will get the weight deposited here, right? Okay. And what is Faraday? Faraday is equals to 1 mole of electrons, the charge carried by 1 mole of electrons, right? Now, what is Faraday's second law, right? Now, let us see Faraday's second law. Now, they are saying that, for example, you have A, B, C, you have A, B, C, they are connected to each other, but now they are asking you the weight deposited, or you can say equivalent weight they are asking you, right? Okay, they are asking you the equivalent weight here. Now, if you talk about this, here molar mass of A, or you can say the weight deposited of A, weight deposited of B, weight deposited of C is equal to equivalent weight of A, ratio of equivalent weight of B, equivalent weight of C. For example, you have two things. Then weight of A divided by weight of B will be equals to equivalent weight of A divided by equivalent weight of B. Right? Equivalent weight means molar mass of A. Equivalent weight means molar mass of A by n factor of A. And what is equivalent weight of B? That will be molar mass of B divided by n factor, that is number of electrons that are gained or lost by B. Right? So you can just simply remember this thing here. I know you are remembering what is this, ma'am. Now, this you can only understand with the help of questions, right? So, I'll tell you what kind of questions you will see in the exam, right? So that is why I have picked up some questions here so that you are able to understand what kind of questions they will give you based on Faraday's law. Now this is the number of Faradays they are asking you. One question is they will ask you number of Faradays. One type of, just remember these two things. These are the two laws. Now we will see what questions they will ask you. Their first question that they can ask you is the number of Faradays required to produce 20 gram of calcium from molten CaCl2, right? So from CaCl2, what is the reaction? You will have Ca2 positive plus Cl plus 2Cl negative. That means 1 mole of CaCl2 can give you 1 mole of Ca2 positive, right? That means this is 40, the molar mass is 40, right? But we need 20 of it, right? So we can say that, wait a minute, the number of Faradays required to produce 20 gram of calcium from molten CaCl2 is. So can we say that 1 mole of CaCl2 will give us 1 mole of Ca2 positive, right? 1 mole of CaCl2 will give us 1 mole of Ca2 positive. 1 mole of Ca2 positive means we can say that it will give us which thing? It will give us, wait a minute, how many electrons it has to gain? If you talk about Ca2 positive, Cu2 positive, to convert it into Ca, how many electrons it has to gain? So that we want the calcium to be deposited, right? If you want calcium to be deposited, 1 mole of calcium will need 2 Faraday, because 1 mole of electron is 1 Faraday, 2 mole of electron is 2 Faraday. So can I say 1 mole of calcium will give us 2 Faraday. But how many calcium do I need? They are asking that you have 20 gram you need to produce. That means 40 gram of calcium will be produced by 2 Faraday. So 20 gram of calcium will be produced by 2F by this 2 only, that will be 1 Faraday, right? If you want 20 grams, so what you will do, this will be 2 Faraday, right? This will be 40 multiplied by 20, so it will be 2. Answer will be 1 Faraday. That means A will become the correct answer, right? Okay. Okay, guys. So one kind of question is this kind of question where they will ask you how many Faradays are given, right? For this though, you will simply apply unitary method. There is no formula for this one, right? Then they will ask you this kind of question where they are asking you the weight of silver, right? They are asking you when nothing is given in comparison. Here you have two things. Here you have weight of Ag displaced by quantity of electricity which displaces this much of O2. So now you have two things in comparison. They are asking you the weight of Ag here, right? Weight of Ag, atomic weight of Ag is given to you, right? So basically this is based on second law of Faraday. Second law of Faraday, right? Okay, this is based on second law of Faraday where you have to calculate the weight of silver, right? And this is weight of O2. This you can calculate. How you can calculate the weight of O2? How you can calculate the weight of O2? By applying mole concept, right? Mole concept again we have here, right? How you can calculate the weight of O2? By applying mole concept. We know that the number of moles is equals to given volume in milliliter by molar volume, right? 22400, right? Then this is given mass divided by molar mass. Molar mass of O2 is going to be 32. So you can calculate the weight of O2 from here. You can put it here. That will be weight of Ag by weight of O2 equals to equivalent weight of Ag by equivalent weight of O2, right? Okay, so just need to put the equivalent weight of Ag. Equivalent weight of Ag is 108 only. Equivalent weight of O2 will be equals to 32, right? So you can put the value and you will get your answer, right? Okay, so the same thing that they have done here. Weight of Ag divided by weight of O2. What is the weight of O2? That is 5600 divided by 22400 into 32. Right? Here it is equivalent weight of Ag, because in Ag it is gaining, n factor is just 1. So molar mass of Ag is equals to equivalent weight, that is 108 only. What is the equivalent weight of O2? Right? Here they have, wait a minute, O2. O2 is basically, it is the mass of oxygen, right? So this is giving us O2 negative, 2 electrons it is gaining, right? Half of this. So it will be 16 divided by n factor is 2. Yes. So it will be 8. Why? Because 16 is the mass of one atom, that is O2 negative, right? And what is this 2 negative means? 2 electrons are lost here. So it will be divided by 2. Answer will be 8 here. So you can just calculate this. Weight of Ag will come out to be 108. Right? Okay. Understood? So now this was also your latest question only, that is 2014. Here 2014 and this was 2020, right? So basically these are latest question only. They are asking based on the apna Faraday's law, right? Now product of electrolysis we have done. Next is last part of today is some of the very small topics, right? Concentration cell. What is concentration cell? Cell in which both the electrodes are same nature, but the concentration or pressure of the species are different. For example, there are two types of concentration cells, that is electrolyte concentration cell and electrode concentration cells, right? So in this case, exactly, you don't need to do this. I'll just simply tell you what you need to do here, right? Chalo, let's see this also. Chalo, let's see this also. Now see this. Here the concentration is different, right? Basically this is having a C1 concentration. This is having a C2 concentration. Rest of the things are same here, right? Rest of the things are same here. Then I will apply the same method here. I will apply the same Nernst equation here, because my anode and cathode both are, I think you are not able to see this, right? I think you are not able to see this. Chalo, I'll delete this then, right? So basically I'll tell you what exactly we need to do here, right? So basically in these kind of concentration cells, what you need to see that in concentration cells, E0 cell is going to be 0, right? So when you will put it in the Nernst equation, that is E cell, E0 is going to be 0, that is minus 0.059 divided by n log of oxidation by reduction, right? So there are two cases here, right? There are two cases here. If you talk about, not two cases, if you talk about cathode, that means reduction is having concentration C1 and oxidation is having concentration C2. So the answer will be C2 by C1, right? This is the same thing that is for concentration cells, right? Because E0 cell is going to be 0 for concentration cells because your electrodes are same. The anode and cathode is going to be same. That is why there is nothing like you will mention that, ma'am, this is E0 cell, how to calculate. E0 cell is going to be 0. You just have to see the concentrations here, right? And number of electrons here, right? Okay. Okay, guys. Okay, guys. Okay, guys. Okay, guys. Too much now. Now the light is going to be very bright for you guys. Let me dim the light here, because for battery though I have like full bookish thing only, right? Let me see how can I dim the bright. Can I decrease the brightness? Is it now audible? Is it now visible to all of you? I think now it should be visible, right? Okay, because everything is theory part only. Now whatever we are left with is theory, right? Now let us see the theory part. So basically we have two types of batteries. One is called primary battery, other is called secondary battery. If you talk about primary battery, in this case it will become dead, right, after a certain amount of time, and it will not be reused again, right? For example, if you talk about our watches, right, when the cell of this watch will become dead, I can't recharge it, it will be dead, right? So it will be over a period of time, battery will become dead and cannot be reused again. For example, this mic, I can recharge this mic, but I cannot recharge. I'm saying I can charge this mic, but I cannot charge a mic which is with wire, right? Because they have that kind of cell which will not be recharged again, right? I cannot recharge it again and again. For example, you talk about your phones. You can recharge it when the battery is low, right? For your laptops, you can recharge it, right? But watches, you cannot recharge it. Now, smart watches, yes, you can, but these normal watches, you can't, right? So the same thing. For primary batteries, it is once they are dead. So you have to replace this. They are dry cell or mercury cell. Secondary battery, it can be recharged after some time. That is lead storage battery and a rechargeable nickel cadmium cell. So these four reactions you have to go through, right? So I can't do anything about it. I'm so sorry that this is in your syllabus. Even I don't like this part of chemistry, but this is interesting if you talk about the applications here. But if you talk about the reactions, yes, I know it is tough. But you have to remember at anode, at cathode, what is happening, right? So at anode, you have zinc is getting converted to Zn2 positive, right? At cathode, you will have, this is dry cell, that is Leclanche cell, right? In Leclanche cell, at anode, you have zinc which is converted to Zn2 positive. At cathode, Mn2 positive, and you have NH4 that is getting reduced to MnOH and NH3, right? And the electrolyte that you used here is a moist paste of ammonium chloride and zinc chloride, right? This you have to remember, and this is important, right? This is important, right? Now, the cell potential is approximately 1.5. That if you even skip, that is fine, but you have to remember the anode and cathode reactions here, right? Then next is your mercury cell. In mercury cell again, at anode, zinc amalgam is converted to zinc oxide. At cathode, HD, mercury oxide is converted to mercury, right? And electrolyte is a paste of KOH and ZNO. This is the overall reaction. And this is the battery, this is the voltage of battery, that is 1.35. Now, because this is having really low voltage, that is around 1.35, that is why it is used in hearing aids, watches. This cell is used. That is called mercury cell. Okay? Mercury cell is used. Right? Okay? Yeah. No, I have eaten, don't worry. I have eaten in between the break, I have eaten. Now, next is lead storage battery. About lead storage battery, if you talk about anode and cathode in these things, right? If you talk about anode here, Pb grinds with spongy Pb. Now, this is a very, very important cell, very, very important cell, because this has been asked in your previous year questions, right? Directly they will ask you at anode what is formed, at cathode what is formed. So, at anode you will have the formation of PbSO4, right? Pb is converted to Pb2 positive. At cathode, you will have the formation of, from PbO2, you will have the formation of PbSO4. From PbO2, you will have the formation of PbSO4, right? And the electrolyte that is used here is 38% H2SO4, and this is used in automobiles, inverters, and it is having a very high voltage. That is why it is used in automobiles or inverters, right? That is why it is a very, very important cell, very, very important cell. This kind of thing that you must have seen in your houses also, right? This big inverters you must have seen, right? That is the same thing. Next is nickel cadmium cell, right? Nickel cadmium cell. Now, guys, this lead storage battery, right? This is a secondary battery. So you must have seen whenever your inverter, right, is not working, what we do, we call up the electrician, right? We say, or electrician, or we sometimes recharge it ourselves, right? We do not replace the inverter. We only replace it if it is not working, if it is not if it has gone, its value is totally gone. Only then we will replace it, right? We will not replace it because we can't recharge it. This we can definitely charge it, right? Okay. What about this last one is nickel cadmium cell. And here this is the overall reaction. This becomes the overall reaction, right? A longer life than lead storage cell, but more expensive to manufacture, has a jelly roll arrangement separated by layers soaked in the moist NaOH and KOH. So this is basically how it looks like. There is a positive plate here, there is separator, and there is negative plate here, right? Okay, and this is the overall reaction that will happen. Cadmium is getting converted to cadmium oxide, and nickel 3 positive is getting converted to nickel 2 positive, right? Okay, so this is the redox reaction that is happening in this cell, right? Now these are the cells that you have to cram, right? You have to sit in your room and you have to cram all the values of anode and cathode. You have to cram the reactions here, right? So that is why I have given it, I have provided this in your notes, so that after the class you go through the notes, right? And also see the NCERT part, right? In your NCERT they have written batteries primary and secondary, and you don't need to do anything apart from NCERT. Do whatever, stick to your NCERT, right? Whatever given in your NCERT for batteries, do just those reactions, don't do over reactions, right? Just stick to those reactions only, right? Okay. Yes, everybody. Yes, everybody. Wait a minute. Yes. Okay. Okay, guys. Wait a minute. I forgot to tell you hydrogen fuel cell, right? So hydrogen oxygen fuel cell, it is actually the best cell out of them, right? So both thermal and galvanic cell convert chemical to electrical energy, but the efficiency is not very high. That is why now we have switched to hydrogen oxygen fuel cell. Now what is this hydrogen oxygen fuel cell? Let us see. Now this is your hydrogen oxygen fuel cell. Here what is happening? At cathode, oxygen is getting converted to OH negative. At anode, H2 is getting converted to H2, and in the end what you will have? Water as the product, right? So this is, right now we are using this, technology because this is pollution free, right? These are the reactions of hydrogen fuel cell, and it is actually, this cell was used for electrical power in the Apollo space program. The water was used for drinking by astronauts, right? So already so many reactions are happening in the space, in the spacecraft. So they used that hydrogen and oxygen, right, for producing water so that astronauts can live and survive in the space, right? This cell runs continuously as long as the reactants are supplied. There is no expiry date of this reaction. As long as you are giving hydrogen and oxygen, this reaction will go on and this will not stop. That is why this is a very important reaction here. Carbon with finally divided platinum or palladium for increasing the electrode reaction, basically inert reactions and carbon electrodes we are using here, right? So this is the full-fledged apparatus of the cell, right, where we are giving it hydrogen and oxygen gas and it is giving us water, right? So this is, they don't ask you in the NEET exam, but that was something you should know, right? That was something that you should know, right? Okay. Okay, guys. So yeah, today to too much we have done, isn't it? Now corrosion, so you can study that yourself also. I have mentioned that in the notes, right? Corrosion, rusting and their reactions also I have mentioned. At anode what happened, at cathode what happened, overall what is the reaction, right? So corrosion also, they very rare chances that they will ask you corrosion based questions, right? But still I have mentioned this here, mostly chances are they will ask you from primary batteries or secondary batteries. if they want to ask, especially lead storage cell, right? Or they will ask you from Faraday's law, right? First or second law, right? Or they will ask you from Nernst equation. Maybe sometimes also they can ask you product of electrolysis or relation of Gibbs free energy and E0, right? So this is at a very low priority, right? If you want to learn the reactions of other things. That is your primary and secondary batteries. Okay? Yes? Okay? Yes, Himanshu. Now I will be teaching on Vedantu NEET English, Vedantu JEE English, and V Karnataka KCTN boards. Okay, so if you're preparing for NEET, you can come here and join the lectures on Vedantu NEET English. If you're preparing for JEE, then you can join my lectures on Vedantu JEE English. Okay, yes, okay. So guys, that's all about today. Now I have one very important thing for you. Let us see what is that thing. Okay. Now you go to the description box here. Now what all you will have, right? These are the offers that you are getting. Now, for example, you want to purchase DNA plus NCERT year-long test series. One of the students were asking about NCERT test series and Tattva books, right? Now, let us see what you will be getting here, right? View course plans, right? Now, you will be getting it for 5499, right? 5499, right? You can just buy this thing and fill your email here. If you're like, ma'am, I want to purchase only test series and Tattva batch and DNA batch, then what you need to go? DNA plus NEET batch, then that means DNA your NEET batch plus test series combos, right? So now here you will get DNA batch plus test series combos. So the electrochemistry that I have taught you in 5-6 hours, I have taken, I think 8-9 lectures for that, right? So you can understand that how much in detail I have gone for DNA batch, right? So around, I think 8-9 lectures we have easily taken, right, for electrochemistry, and that all the classes were of sometimes 2 hours, 2.5 hours. So you can imagine that, right? How much detail we teach in DNA batch, right? Here also we want to, I to try my best to teach you in detail, but I have less time, so that's the reason, right? Now, next is, if you want to go for only DNA batch, then you have this thing. You can click here and view course plan, and then you will get your course, right? But if you ask me, ma'am, what is your advice in this? I would advise you, if you're looking for a good test series and practice book, then go for DNA plus NCERT plus Tattva books. If you have already Tejas book or Tattva books you already have, right, then you can go for DNA plus NCERT year-long test series, right? Okay? Okay, students? So, yeah, that's all. Now, one of very, very important things. Now, if you're like, ma'am, I'm already a part of DNA batch. I don't want to purchase DNA batch. I just want to have test series. So, if you want to have online test series, click on this and you will get to the portal where you will have your online test series, right? And you can just purchase it here, right? Then if you want to have your offline home test series, you can click here and you will get your offline batch test series, right? That is for 1499. Then if you want to have flashcards, right, you can just click here, right, and you will get to the portal of flashcards. So now I would advise all of you to purchase one thing. Do you know what is that thing? What is my advice? My advice is that all of you should have flashcards. I'll show you how flashcards look like, right? This is how flashcards look like. Wait a minute. Let me show you that. This is how flashcard look like, right? And why I am telling you this again and again, because these are actually very, very good for your revision. And if you ask ma'am, minimal I want to spend and I want to get the best out of it, then spend on flashcards, spend on tattva books, right? If your theory is really strong, if you're self-motivated, you can do that yourself. Spend on Tejas books, right? Okay, Tejas books really, really good. The theory is really good. The questions are really good, right? So practice from that and spend on test series. So these three things, even if you are already scoring 700, you should spend on this thing. And this is so applicable for all the students. You are going in some offline institute, online institute, whatever, you should spend on this flashcard. It is like really good for your memory. It is really good to recall the reactions, to really good to recall the naming reactions, to recall the formulas, right? All of these things are mentioned in a very short format, right? Okay, yes. Chalo. Okay, then bye-bye. Yes, I'm very tired now. It's been like such a long, it's 11 p.m. already. I'm so tired. I can't tell you. My legs are literally paining now and I'll just doze off now. Yes. Okay then guys, bye-bye. Take care. See you all in the next class, and next class is going to be on Saturday, right? I'll let you know about the chapter that we are going to do. Most probably we are going to complete maybe amines or maybe aldehyde ketones carboxylic acid part 2, right? We will see what we want to do. Okay? Yes? Okay, then bye-bye. Take care. See you all in the next